Welcome to Uhere Studies
We will
Center.
be having a seminar today titled Intelligence and Meaning.
And our guest speaker is Ezeukwu Osuagwu, who is an Uhere alumni. Sit and
The
enjoy.
value packed seminar.
Good morning. Yes, today we're going to have an essay on meaning and intelligence. This essay is dedicated to Uhere Study Center. Made today, March 2025. My name is Mr. Osuagwu, and you are welcome. Thank you for being here. The signal and W1. The scope of intelligence today is being expanded rapidly into spheres of abiotic mass. As we hear and continue to re-echo the common slogans and social rhetoric, such as data is the new oil. And yet what is less discussed is that data itself is sampled via signals. Itself one of the 6 types of signs. We further assert that the signal is the governing sign of the joint world, which for the purposes of this lecture we shall call W1. In astrophysics, W1 is termed the cosmos, bounded at the cosmic horizon, the calculated distance in astronomy, and this is well known. Beyond the cosmic horizon, photons traveling back to us on Earth can never be observed due to the redshift. Redshift effects were first determined in 1912 and confirmed by Edwin Hubble in 1929. That is, the rate of the acceleration of the expanding universe beyond a given distance from the Earth in light years retires into oblivion, the possibility of light itself reaching us from the surface of the horizon, given infinite time. Now, what this means, if we imagine this to be the cosmic horizon, right? Because the universe is expanding. How did the astronomers know that the universe is expanding? If light is traveling, right, backwards, and something is pushing it backwards against its direction of travel, then you experience what is called a redshift. Like you would have noticed when a fast bike is passing you and is making noise, right? You know the Doppler effect. When a sound crosses you, just changes in tone, right? Exactly. So something like that happens to light too. Imagine you are here in the center, maybe on X, and this is the cosmic horizon. The light or events outside here can no longer reach you, given that the universe is expanding, even at speeds as fast as that of light. It is as though we now know that there are events in our universe that are simply unobservable, given the governing semen of the joint world traveling in vacuum at a fixed speed, c. What is the speed of light? That's right. A supernova beyond the cosmic horizon can be referred to as an event occurring in the regions of electromagnetic darkness. Impossible to observe, but yet still existence in W1. The only picture we need for this lecture is on the board, so just follow it as a model, right? Okay. To conclude this beginning of our interaction with signs, we could first assume that the governing sign of the joint world, W1, is the signal. Itself simply the fastest phenomenon observable. Einstein, in the general and special theories of relativity in physics, has mathematically demonstrated that light is the speed limit of all mass. The transformations of Lorentz demonstrate a division by zero, which will lead to the phenomenon of infinite mass if any given mass, m, attains exactly the speed, c, in theory. This allows the field equations to be consistent with the boundaries of the speed of light, which is the limit of the speed of all mass in W1. An asymptotic approach, right, is permitted, but there can be no reaching it. We shall revisit asymptotic functions as we begin to gain further insight into the natures of what is called machine learning, and remain ever resolute to show differences from the nature of learning in biotic mass or in living organisms in general. A question?
Yes.
Go ahead.
Sorry.
Yes.
I don't know that it's happening only to me.
Oops.
I'm absolutely lost.
That is true. That's the whole idea. Just stay with me.
Okay.
Stay with me. Stay with the model and stay with what you hear. Take notes, right? Write down your questions, and gradually we'll get to a middle ground. Don't lose sight of the talk. It's meaning and intelligence, right? That's it. The space of simultaneous events in W1 is large and could be referred to the harmonious axis of information events. The space of chronological events in W1, equally large, itself referred to the melodious axis of information events. In the theory of music, when you play 7 notes at the same time, that is what is called the axis of simultaneity. So you have 7 different notes occurring at the same time, right? And then it's pleasant to your ear if the pianist knows what they are doing. Now, once they leave those simultaneous sounds and then spread it in time, then you have melody. So in the theory of music, what is simultaneously occurring can be seen in y-axis, and what is distinct in time can be seen in x-axis. One is called melody, the other is called what? Harmony. Have you heard of the harmonic function in mathematics? Exactly. So it's the space of things that happen at the same time, right? While there's also another space of things that happen in distinct times, right? That's what we are trying to refer to. Now, if you think about every nanosecond in the joint world, every nanosecond, right? And the space of simultaneity in the entire known universe, that is the space of an information event in 1 nanosecond. And then in the next nanosecond, you are in the melodious axis. Right? I'm trying to show you how vast the information is in the cosmos. It's really big. Right? It's really big. So you know the Avogadro number in chemistry. So information events also occurring in liquids. They also occurring in gases. They also occurring in our minds here, right? Interactions with plants, everything you see. So if you now freeze 1 nanosecond in simultaneity and then capture all of it in the cosmos and move to the next nanosecond, now I don't even think there's any storage technology in the world that can hold that data. Do we all agree?
Yes.
Can you imagine it? Yeah, let's be going. Okay. We already know that there is an intuition that time itself, once gone, can never be revisited. We should also model time as a very long line or ruler, dividing the past from the future and marking where we stand as the continuous now. This can be imagined especially in W1, given the governor of signs made here for us but before us. This is called the signal or light. To take as our boundary the cosmic horizon, right? And to hold the speed of light as the limit of simultaneity is to capture and divide space of events originating at any world point as center in W1 into three referred in the Hermann-Markowski's papers called Space and Time on Relativity as time-like, space-like, and like-like zones. I would advise, how many of you are in physics and astronomy? Nobody? That's cool. How many of you in engineering? I reckon. Okay. How many in biology? Great. How many in chemistry? How many in arts? Right. This is good. We'll see the special reason why arts is very powerful, right? As opposed to what you might think. To look at the sun now is to look into 8 minutes ago. How many of you knew that? Yes, whenever you're looking at the sun, you're looking at an event that has happened 8 minutes ago. Yeah. Oh, okay, it's getting interesting. Okay. And to be blind to the next 8 minutes of the sun itself. That means if the sun explodes now, you will see it still. 8 minutes later, you see an explosion. Okay. So the sun, your now is the sun's 8 minutes ago. And you're now looking at the sun is the sun's future 8 minutes. Right? Now, this is because of the enormous distance separating you and the sun. That's 93 million miles. And at 93 million miles, if you travel at the speed of light, in vacuum, you will reach here in 8 minutes. That is why those probes that are sent to Mars, if they need to communicate with NASA, they have to send the message, right? If NASA receives a signal from Mars now, it understands that that signal may have left hours ago, given the distance between Earth and Mars. You have to understand the joint world. I started this lecture by showing you that the governing sign of the joint world is the signal. Right? The story doesn't end there, but it's very important if you really want to go very deep into machine learning, artificial intelligence, but most importantly, distinguish it from meaning. Nothing new is said here except to remind us that the governing sign of the joint world is light itself, at the speed of light, and to remind us that in this journey into the mysterious nature of meaning and intelligence, we cannot avoid semiotics, which is the scientific study of science. On this note, I welcome all of you to her study center. That is those of you that are visiting. And I want to make it clear that this place and space is ancient. It represents many things in general and reminds me specifically of much more too. This lecture is in honor of this study center, and I wish that Lions here and all those that have joined us in the emergence of the many events in W1 will see through the signification of this lecture and derive from it much knowledge and wisdom to guide and guard into the uncertainties of our joint future. To conclude this section, we heretofore declare as follows: the first hypothesis. The governing semion of W1 is the signal, itself the limit of speed upon W1 in proper time, the signal being a quantity that varies in continuous or discrete time. Who agrees with me?
I don't understand.
The first hypothesis, the governing semion of W1 is the signal, itself the limit of speed upon W1 in proper time. To understand proper time, you have to study the general theory of relativity. There is a technical word called proper time, right? Okay? The signal being a quantity that varies discretely or continuously with time. As the mediating sign of causality in effect space, it has been ordered to relate cause and effect in W1. Most of us studying in the sciences are actually studying cause and effect, right? This reaction happens under the presence of these enzymes, and we have this chemical kinetics follow, right? That's it. They're studying cause and effect. But I believe that's half of the picture. I'm trying to convince you that that's half of the picture. We can call this the empirical effect space, EES, right? And please, just to note, there are many terms you see here that are nowhere written anywhere in the world. So some of the concepts that you may find in literature out there, I will try to help distinguish, but there are some of those that are completely coined for the purposes of this lecture, like EES, right? An effect space is known, but they claim that the effect space is equally empirical, right? There's something trying to be pushed across here. All data that the machine learns to perform inference with, right, was mediated by the signal in a provenance ordinal, which we shall call the first ordinal of information events. What is inference? Can anybody answer what inference is? Yes, go ahead. Yes.
Inference is the ability to draw generalization about a particular detail sample.
Yes, okay. So this is the general idea, right? You are very interested in machine learning. Yes, okay. Now, inference, to break down what he said in basic English, is the ability to make a guess based on evidence you have now. All right? So make a prediction based on available evidence. So if you make a prediction based on evidence that is not available, that's not inferencing. Okay? So the ability to make a prediction like, oh, it's going to be sunny tomorrow, right? Based on the evidence that it is sunny today, right? That's inferential reasoning. And there are many types of inference, but we'll get to those shortly. So all the data that the machine learns to use to perform inference, right, was mediated by the signal in a provenance ordinal, which we shall call the first ordinal of information events. For to sample the temperature of fluids using sensors in a time series is to register upon the thermometer the effect of the cause, which is the heat conducted by radiating or radiated by hot bodies. So something that is hot would register on a temperature, on a thermometer, sorry, wouldn't it? Right? It will register on a thermometer. And yet, it is registering there because there is a what? Heat signal. Okay? Don't forget. You even hear me because of what? What type of signal?
Sound.
Sound. Now, if you remove all the air from here, you would see me like this. Right? Because there will be no pressure pushing on molecules to get to your ear. So when I say that the signal is the governing sign of the joint world, it is a serious affair. It's an engineering affair. Right? It even goes beyond engineering into the deep sciences. Right? There are many types of signal. There are chemical signals, there are heat signals, there are vibration signals, there are electrical signals, there are electronic signals, right? There are all types of signals. Even the GSM that we browse, right? The data, all of those are what? Signals. Okay. We can take the domain of information events to be the domain of the integers in mathematics, or the domain of integers. We carefully observe that we have avoided the zeroth ordinal. I told you it was the first ordinal of information events. And also avoided the negative ordinals, because integers start from 0 and divide into 2, into the negative and into the right, as opposed to natural numbers, which do not have negatives, right? Okay. Now, we carefully observe that we have avoided the 0. To approach these, we must wait for the revelation of further worlds. For now, we have W1, right? The joint world. In the section to follow, we shall together observe these things. But in conclusion, without the signal, there is zero information in W1, the joint world. Should we try this by experiment?
Yes.
Yeah.
Yeah, the experimentalists are here. Okay. What is the least energetic operation you can perform with one of the organs of your body to divide the information in the universe exactly into half? What is the answer? Who did that? Yes, that's the high five. This is good. Now let's try it. Everybody close your eyes. Open. Now when you did it, the information in the universe divided into two.
How?
Oh, the information is not divided into two, right? Okay, go ahead, close your eyes. Open. What did I do when your eyes was closed? Exactly. For those that their eyes were open saw me. Precisely. It's a very simple operation to close your eyes. But when you close your eyes, you just shut down one of the 6 classes of signals, which is the visual signal. And it so happens that the visual signal is what we all refer to as what? Radiating light from the sun. We are seeing because of the sun, right? The radiation is entering and is moving at speed of light. So, if you shut your ears, would you rather be deaf or blind? Let's take a guess. Who wants to be blind and hear? Who wants to be deaf but, who wants to hear and not see? Or who wants to see and not hear? Right? So each of these signals brings information to us. Right? But we all know that we have brothers and sisters on earth who are blind and who are deaf. But maybe for the first time you are beginning to see how they deal with information when compared to you. Right? It may look like a simple assumption, but try walking around the whole day closing your eyes. You are going to find the most basic operations difficult. Is this true? Okay. Now, this is, and I ask the question, why was this confirmation so true? If you shut your ears, the quantity of information you can absorb is higher than the quantity of information you can absorb if you shut your eyes. Right? So it tells us that the eyes does what? If you try to quantify information, it takes in more. Especially if we are dealing with the semion of the signal. Remember, it is responsible for the joint world. Let's proceed to the symbol and W2. There exists a private world which we shall call W2, itself the space of after effects. For when an information event occurs in W1 in the presence of a semantic machine, that is a machine capable of originating meaning, and for the purposes of simplicity, one able to interpret signals to any degree. Such machines usually hardly come in direct contact with the cause or origin of signals. For instance, it is sufficient that a distance exists between such machines and the source of signals. Example, the distance between me today giving this lecture and you observing and listening in W1. It is equally clear and beyond dispute that after this lecture has come to conclusion and some time passed, it is possible that you recall, retrieve, remember aspects of it in a future that has not yet come as at now. Is this true?
Yeah.
Yes. This is our usual experience for which we as humans have come to normalize and accept equally as normal. I state to you today that this is a special capability and possibly a rare gift in the cosmos. If we assume that there is a space for whose specific locality in W1 is irrelevant, like let's just, you know what a mathematical space is? Yeah? What is a space in maths?
XYZ now.
Sorry?
It's not the XYZ. The XYZ now. That's
Oh, yes, that's a Euclidean space, right? X, Y, Z is a Euclidean space. So it's a space where the Euclidean norm holds. That's where the Pythagoras rule holds. You remember Pythagoras? Yes. Exactly. That kind of rule, right? That's a Euclidean space. In a Riemannian space, like the space where astrophysicists work, space is bent, right? The norm is bent. Okay? So over very large distances, space bends. Or in the presence of very large mass, like a black hole or a sun, it also bends. So they are vector spaces, right? Who are the engineers? You heard of vector spaces? Right? Those in mathematics, you hear of non-Banach spaces. These are spaces. I just want you to know that in mathematics, a space is an object. Just like your algebra, okay? Your distribution in probability, right? This is a normal distribution, right? That's a mathematical object. There are many types of mathematical objects. Space is one of them. It's one of the most basic objects, right? Okay. All right. Now let us assume that this space exists. Its locality is irrelevant, but that it keeps the residue of information events occurring in W1, right? After they have occurred in proper time, then we arrive at a space that has a special property for which we should call the after effect space. A space that activates or goes into excitation after the occurrence has reached subsidence in W1. Like I stopped talking now. Right? And some minutes back, you were hearing what? Sound of words and sentences that make meaning to all of us. But after I stop, you can still access that information. Because there exists a space of after effects, right? Cause and effect is making my words reach your ears. When I stop, it does not mean you cannot still retrieve what I said. But you don't retrieve it exactly at the time I have spoken. You retrieve it afterwards. So this is a small intrusion into what the space of an after effect, right, could be. After effect. After the effect has passed, right? Yeah. It kicks off. All right. A space that activates or goes into excitation after the occurrence has reached subsidence in W1. This is what we call W2. It is a private and unique space. It is prime for these reasons. We shall call this space the affect space or A space. This is what we call W2. So we have two worlds. One is in the internal environment. One is in the external environment. But there is a bridge between them. This is what is referred to as Markovian blanket. You cannot see through this from the outside. That's the purpose of a Markovian blanket, right? Cause and effect rules supreme here as the governing principle, determined by a semion called signal. Cause and effect is the governing principle here, and the governing semion is symbol. The signal is a quantity that changes with time. The symbol is a quantity that stays fixed in time. Okay? Are we getting the picture? Now, right, okay, that's fine. So, this is the empirical affect space. Empirical effect space. The affect space, its principle is cause and what? Affect. Right? This principle is cause and effect, which we all know and study in the sciences. But don't forget that psychologists study affect. Okay? Do we have a psychologist here? If you meet anybody studying psychology or some aspects of neuroscience, they study affect much as you study effect. Okay? In basic mechanics, if two colliding bodies hit, at times you calculate the net momentum, right? Good. Now, things like that don't happen in affect space, right? Because things like that happen due to cause and effect in the joint world. Now, the affect space is private, but there's no denial of the affect space because it's the space of our experiences. You see why psychologists study it. Now, it's also an after effect space because each of us can retrieve or remember memories from childhood, right? But none of us are children. So where is that information coming from? You say your memory, right? But those that are in neuroscience have not been able to localize where it is in your brain physically. They can say that this region of the brain or this hemisphere is responsible for long-term or short-term memory. But there is no placing any XY into picking out a particular event that happened when you were in nursery school. Right? Okay, so from a modeling perspective, it's good to treat it generally as an after effect space, a space that retains after the event has happened somehow, right? Because we are modeling here. This is what is called modeling, right? To kind of model something that maybe someday some algorithm could exist to do what? Translate it into a computational model, right? Or if it is an MP hard problem, it stays where it is in the world. That means you can't write any code to bring it into the computer, right? Okay, let's keep journeying. Just stay with me. Okay. For when an information event occurs in W1, the presence of a semantic machine is capable of originating meaning. For the purposes of simplicity, one able to interpret signals to any degree. Okay? Okay, so given the uniqueness property, we state that each natural semantic machine has an affect space. Each natural, right? Natural has an affect space. And nothing stops us imagining that in the surface of the interaction of the joint world and private world, we can assume a persistent interaction filled with enforcations of causality itself. There is a theory of bifurcation. Do you know what bifurcation theory is? It's like your code now in your machines, right? When you have a coin and you toss it, how many possible outcomes? Heads or tail, right? This is what is called a bifurcation. Okay? Have you heard the poem, Yam Porridge Hot, Yam Porridge Cold? How many of you heard that poem? Yam porridge hot, yam porridge cold. Some like it cold, some like it hot. Some like it in the fridge, what? 9 years old, something like that. So that poem has what? A trifurcation. Some like it hot, some like it cold, some like it in the fridge. This is what's called what? Trifurcation, right? And if you continue, you have what? 4, right? And as we continue, we end up in what? An n-forcation. Something that divides into n ways. Okay? And actually, in most natural phenomena, you have cascaded n-forcation. So something divides into n1 ways, and this one divides into what? N2 ways, and this, do you understand? And these are regions. This is what bifurcation theory basically talks about. You find it in chaos theory and a lot in biochemistry and in chemical dynamics. It's there because some of these things are also learnt by the AI, is it not? The AI learns chemistry too. It learns physics. It makes predictions in radiology, right? All types of data sets come to the machine, okay? And I started by telling you that today, the machine is said to be intelligent. But the machine is what? Abiotic mass. It's material. It's not made of what? Living matter. So we want to be able to see if we can begin to distinguish the intelligence of the machine from what? Meaning, which we are standing on as a ground for what? Natural intelligence. Okay? That's the general gist of the lecture. Okay? Okay, let's go faster. The division of causality into the space and effect and space of affect is the greatest evidence for the existence of a distinction and codependence of worlds. So, what this means is that if there's a cause here, in reality, in the presence of a semantic machine, it is not that the effect alone is felt in the joint world, right? Because effect can be felt in the joint world. That's why the signal measures it. But the affect does what? Goes into the private world. Now, this can then look like causality itself is bifurcated.
Use an example.
Okay. Thank you very much. How many people here share the same name? The same first name? Now, this is a difficult search space, but it's possible. right? Okay, so I wish I could find two people that share the same, but then let's give an example. Now, listen to this sound. Are we all listening? Okay, just to help even magnify it. Did you hear it? You all felt the effect. It is felt the affect. Pain is affect. It's embodied. Didn't you feel some pain? Did you feel pain because of that sound? Precisely. So there's a cause, but it has divided into affect in his W2 and remained as effect in all the what? Joint world. Because the signal carried that information, but the symbol stayed fixed in his own affect. Did it pain you? It's true. Right. So we are beginning to get the gist, right? That events that happen in the joint world divide. And they divide every time when you have what? The presence of a semantic machine. And we'll prove it with one more experiment, just like we gave an experiment on the, just slightly towards the end. Okay. In the theory of numbers in mathematics, and specifically the continuum hypothesis, we shall designate the affect space in the domain of complex numbers. I think that's what complex numbers are for, right? Just to, anything you don't understand or can't quantify, just throw I into it and check whether your model can work. Yes, so for phenomenon within it influences W1, but like events beyond the cosmic horizon, these phenomena are not observable with signal. The pain, what's your name? The pain Chukwuemeka felt is not observable with signals, right? But are observable by the second semion governing the world, which we call the symbol. He felt it. And of all the space of pains he has felt in his life, this one takes a scale in his own internal scale. We have a question. Go ahead.
Sorry, I wasn't hearing.
Okay.
But my question is,
Yes.
from your explanation, it means that a human being is perfect semantic.
Okay. This is interesting. What do you mean by perfect?
For instance, you said that a semantic machine can understand every type of signal, both symbol and signal.
Okay, beautiful. I like you, the direction of your gist, but let's make it very precise. We are saying that the natural semantic machine, those that we've seen in nature, bats, butterflies, human beings, itching on wasp, right? Those ones are capable of bearing an after effect space. And they are also in the joint world. Do you get it? Now, it may imply that I'm saying that the artificial semantic machines may not be capable of one of these two worlds. But already by intuition, we know that they are in the joint world because you can see the servers in the data center. Some of them are running AI models. They are there with you. You have ChatGPT in your phone. How many of you use it? We're in trouble now. we're in trouble now. We're not. Okay, so please take a seat. But you are very much right that your claim or your intuitions are in the right direction. We've not yet demonstrated it, but we are getting there gradually, right? That this natural semantic machine is capable of bearing two worlds. One is joint, the other is what? Private. It is possible that the artificial one exists only in the joint world, but we have not yet done what? Proven it. But we are getting there. Okay. Now, each world has a time. Not so. The W1 of the joint world has proper time, or linear time, or clock time. What's the time now by your clock? Yes, we say 12:18, and we all take our reference from what? The Greenwich Mean Time. Okay? That's a scientific convention in SI units. Is it not so? Given another part of the world in another time zone or in another time regime, the time may not be 12:15. So time as we know it is a convention. Okay? But this is clock time because it's ticking in seconds. Okay? I propose that in W2, or the private world, it has a hyperbolic time or a non-linear time. The hyperbolic time can be geometrically represented by the catenary, showing the past, present, and future. In theory of algebraic equations, we can represent it by a hyperbolic function. So we are saying that this is what? Non-linear time. This is proper time. Why is it non-linear time? Geometrically, it's a catenary. This is the past. This is now. This is the future. Not so. It's not a simple graph. Yeah. Okay. And if you check the geometric representation of this in algebra, you will find this equation. It's called a catenary. Check it, or use your MATLAB and plot it. See what it looks like. If you vary the values of k, you vary the saddle point, or the sag, right? That's your point of minima. Right? Calculus, guys.
I thought that it should just be a straight line.
Yes, why not? So the claim is that this complex time or hyperbolic time is this, and the Minkowski time is what? Linear. So this is again past, now, and future. But there's a significance, as you know in the theory of calculus, that a function has a minimum or a maximum. It has implication. And also linear equations have implications for what? In learning theory. So what is straight is not bent, and what is bent is not straight. In models, this thing could have different implications, right? Okay. It would be interesting for the young ones to graph this, and if the space of affect has a trifurcated time, and the space of effect has a linear time, we could ask if this is a necessary property of all semantic machines, right? If it is a necessary property. Or can we have semantic machines without the capacity of after effects? That's semantic machines that don't consider W2, complex time, affect, or symbols. Okay? But we don't yet know. We are just thinking about this together. Even me, I'm thinking about this. Right? Okay. Emmy, do we have coffee? Some people are feeling sleepy.
Maybe you can give them some water.
If you are feeling sleepy, there's water for you. Okay. And it will also be interesting also to determine if there are relations between intelligence and meaning. And we could jointly conclude on what it could mean for a semantic machine not to be an after effect space, and therefore to be unable to perform inferences constrained in hyperbolic time. We remember inferences again. The ability to make a prediction of the future given what? Current information. Okay. The symbol, unlike the signal, is fixed with a linear time, but changes in hyperbolic time. Right? For the symbolic is the governing semion of affect space itself, the principal mediating sign for the second division of causality into the space of affect. And if we could even begin to look at W1 as half of the picture and recall that the other hidden half is within its second division into W2, then we can say that causality is bifurcated into two spaces, empirical effect space and empirical affect space. That which is empirical comes from empiric in etymology. The empiric relies solely on observation or experiment. That's what empiric means, right? That something is empirical means you have observed or measured it directly, right? This was made so before us. This ability for something to be empirical but equally unobservable in the joint world, W1, does not imply that it is unobservable in the private world, W2. Does it? Maybe the bearer of the W2 is able to measure. Just like Chibike, right? Chukwuemeka was able to measure his pain. And all of us hear it. Now, if I tell you to quantify his pain by any empirical models, It's tantamount to telling you to quantify itching. You know what itching is? Your back is itching you. How do you quantify that? Under what scale? Exactly. Even closest in geometry, you would be thinking about fractals. How many of you have heard of fractals? Right, so fractals are shapes, geometric shapes that have fractional dimension. Right? It's very interesting. Mandelbrot did a lot in fractals. It's in mathematics, right? They are fractal sets, like the Julia sets. That time in third year, we used to, or rather, I used to observe some geniuses write code that modeled fractals, right? And they give you these very beautiful flowers, right? From very basic equations, you get to such complexity. So check out fractals and check out if you can write code that displays fractals. Yeah, it will make a lot of sense to you. Observability in the experimental sciences as such requires a reformulation that allows for the subjective experience and the objective experience to enter into a kind of formal union. This is one of the powerful gifts meaning can offer to the scientific episteme in general and to the philosophy of science specifically. To conclude this section, we therefore declare as follows the second hypothesis. The governing semion of W2 is the symbol, itself the grounds of W2 in hyperbolic time. The symbol being a quantity that is fixed in proper time, but varies discretely or continuously in hyperbolic time. As the mediating sign of causality in affect space, it has been ordered to release cause and affect in W2. We can call this the empirical affect space, or EAS, a space where we can relate causal history and find consistent the principle of cause and affect. Our experiences affect us. This is a fact. They don't affect us alone, right? At the time where it happens, there will be some effects, okay? But after it happens, there will be what? Affect. Yes. Okay, you are getting the gist now. So it's not so complex after all. It's just basic information relayed with scientific terminology, okay? Okay, that's good. All data that the semantic machine learns to perform inference with in W2 was mediated by the symbol in a provenance ordinal, which we call the order ordinal of information events. For to sample the pain of your limbs using the sensory neurons of your brain in a time series is to register upon the memory the affect of the cause, which is the inflammation or fracture radiating pain in your body. We can take the domain of information events to be C, or the domain of complex numbers. We carefully observe that we have avoided the nth ordinals, where n could be positive or negative. To approach this, we must understand that the zeroth ordinal in hyperbolic time is capable of reaching out to the past and the future, given that the 6 grounds of affect space transcend linear time into the regions of nonlinearity. Experiment. Please finish up this phrase. Twinkle, twinkle. How did you know? The signal didn't exist. I just stopped in twinkle, twinkle. Where did the rest come from? The affect space. A round of applause for ourselves. Is the second experiment not confirmed? Remember, it was necessary that you said little star. Where did I stop? Twinkle, twinkle. Right? Go ahead, please.
Like, for example, this demonstration just did.
Yes.
And like, if I'm seeing one action can generate more than one signal.
Yes.
I mean,
yes.
And generate more than one signal. So I'm just thinking about that. This affect is a subset of an effect.
Effect, okay.
And my assumption clear.
Yeah, this thing I'm saying here, I don't know completely. Just see us as colleagues. We are thinking about it together. Honestly. And you have said something that is quite right. He's saying that the affect is a subset, right? So by the laws of merenomy, we should have this. Is that not what a subset looks like?
Yeah.
But is that not what the diagram looks like?
Like the diffusion, like the way you deduce from this place.
Okay, this division.
Yeah.
Okay, causality. Okay. So when I said twinkle, twinkle, you said what? little star. Right? What's the meaning of little star? A star that is small. Exactly. But if you follow the physics of the situation, only the physics, you are not supposed to arrive that the signal that you said back to me, which is little star, means a small star. There is no equation of physics that can take in that voice signal, right? You know, little star, right?
Yeah.
Phonetically, it's like a chip. Have you seen audio signal before? That's how it looks. Yes.
That is like for me, affect is one small and effect, like one small, like affect is one
It's
small
after effect. Right? There must have been an effect that led to affect. That's why it's called the space of after what? Effect. So twinkle, twinkle, right? Little star. Those that had heard the poem many times, you can use the common parlance that you've come to memorize it, right? And yet, that is not necessarily what happened, because there are many things that are in your memory that you cannot retrieve now. But given the relevant signal, what happens? It just comes out. You see somebody's face. Ah, I went to primary school with you. The person was not in your memory, right? Has always been in your memory, sorry. But you've been moving around the joint world and just merely seeing the contours of the face. The person hasn't talked to you. What happens? There's like an avalanche of what? Exactly. Is that it? Can you have any physical measure to that thing? And not only that, you recall that person, you recall joint events with the person. If it's somebody that you had a fight with, you remember. If it's somebody that was always coming first to your, do you understand? He was very good in football. All of those things come together. Now, this actually has been sufficiently demonstrated in the theory of memory. This theory is lost. It was a theory by Wolfgang Semon in 1923, right? And it's called the MEM. It's in fact, it's the richest memory theory I've seen. Go ahead.
Sir, based on, you're talking about equation. Based on the equation, equation is used to generate for if you use it for the quantify some certain things.
Exactly.
Can you quantify an emotion?
No.
So why are you assuming to generate equation to bring out that? I'm just
No, we're not generating any equations here. As a matter of fact, anybody that brings out equations from the after effect space is hitting probably a Nobel Prize or something, right? Just like we said, you can't quantify itching, but yet it affects you. There is no known scale that is joint. There is no scale that is what? Joint. That means exists in the joint world, like temperature, pressure, that has standard what? Units of measure agreed in all the scientific community that can help you with matters of affect. It's just something we generalize with one word called the subjective, which the psychologists study what? Sufficiently. But I put it to you that I just brought out a signal. Twinkle, twinkle, and what happened? Just effortlessly. And prior to doing that experiment, none of you were thinking of the poem, Think It, Think a Little Star, right? Nor that it will be necessary and mandatory that you respond with what? Little star. And yet, the little star is an English phrase. It has meaning. But if you look at its footprint in physics, there is no way you can join from that signal into what? A star that is little. It is because it's what? Symbolic. Now, I want you to be very empirical. To be empirical is to measure and observe. If I give you the voice signal of little star, you are going to see a graph called a chep, right? That's all. They are called observables. Go ahead. Yes. Yeah.
All right. First of all, my question is, you gave an example with the signal coming
Yes.
and someone responding
Yes.
from the affect space, and So, like, my question now basically is that from the affect space, the response coming there, is it because there is a mapping
Yes.
of signal from that is like the corresponding signal on the response? Is the mapping existing in the affect space, or is it just this, the response that is there, or both of them? And then how does it, like say, go with retention? Because I've studied a book about memory and retention before,
Yes, yes.
and I think his name is Frederick Bartlett. He was talking
Yes.
about the relationship of retention with time.
Yes.
So, like, how does
All these things.
the signal and the response go with retention? Like, are you not retaining because the mapping does not exist, or the signal cannot find the appropriate response? I don't know. Just
Okay. What I just want, let's use one domain, because we are very cross domain here, right? Engineering is here, biology is here, all sorts of things are here, psychology is here, right? So let's stay with one scientific body called semiotics. It's a scientific study of signs. There are two signs on this board. One is what? Signal. The other is what? Symbol. Right? So it's almost like these signs have their domain. All I'm trying to say is we should be able to see the form of the sign given a world. In the joint world, the measure of the signal is either by what? Pressure, electric current, or right? Something. But I want to tell you that the physics of the situation is that that is what got to your ears. But what came out was again a signal. Is it not? A signal came out. Little what? Star. I don't know why, and why didn't you ask why another shape of signal came out? Right? You are very right. It's because of memory. If you have not heard that poem before, right, you will not say Little Star. Our cognition has 6 components: memory, attention, language, thought, perception, and emotion. This component, right, has 3 sisters: attention, retention, and protension. Now, you may not have heard of protension, but good footballers they have good protension because they put their leg where the ball is going. The position, right? So they have a very fast predictive, right? Now, people that have very good retentive memory can remember the last 30 minutes of what you said. That's retention. But then attention is the ability to absorb a lot of what? Information in the now. Are you seeing that the geometry of the 3 sisters of attention are looking like what? Hyperbolic time. Maybe that's what the author was saying. Short-term memory of the past, retention. Short-term memory of the future, protension. Ability to soak in a lot in the immediate now, attention. Right? I think the psychologists will tell you a lot more about this, but where I'm going is that the little star came from memory. Okay? But it came from memory because I don't know why, but I guess that every nursery school does what? Teaches that poem a lot. There are other poems, right? Yeah. Emi, how much time do I have?
You have all the time in the world.
Okay, let me just be sure. Right? So they teach this a lot, okay? They teach, okay, go ahead.
so what do you teach students the point with twinkle twinkle?
Yeah.
It's not a little star anymore.
Exactly. Believe you me, when I say twinkle, twinkle, little, when I say twinkle, twinkle, they'll say what? Large star. This has actually happened in the past. Around the Middle Ages, there were some poems from the East, right, that had 2 versions. And the first phrase of the poem was common to version what? A and B. But if you go to cultures where version B right, is much more what? Recognized than version A. Once you say this first phrase, let's call it theta, just like I said twinkle twinkle, those people in that culture would do what? Necessarily go B. And if you have been having flavors of A and B, then you now arrive at what? A weighting function. Based on which one has more weight. What happened? That's the one you say in the presence of this signal. Now, we are arriving at some deep implications of the theories of Joseph Wolfgang Simon. This principle is what he called euphoria. The one before it are what? Engraphy. These are the two basic principles of the theory of memory. We are getting here because the machine does not remember, but it can recall. It can retrieve information in any part of memory, right? A machine in Seattle can retrieve information in Dallas, right? Provided there's what? A fiber or communication link between them. So to recall and to remember are not exactly the same thing. And the deeper reasons are found in this theory of memory, because for you to be able to distinguish recalling from remembrance, you must also ask yourself how information is stored in experience and how information is what? Stores governed by the laws of mass. This is me daring the whole situation. I claim that W1 is governed by the laws of mass and that W2 is governed by the laws of information. If I have a banana, divide it into two, give you one. I have half, you have what? The other half. If I share my knowledge with you, it doesn't erase in any way. So think about the banana of information. If you cut it, it replenishes itself. The laws are not the same. Otherwise, people will stop telling people things. If you tell somebody something and by doing that, you divide that in your own mind, will you go ahead? No. We'll all be holding it like we hold what? Our physical items. So the laws of mass and information not look alikes. They may share symmetries in some way, but there's something more at play. I don't have the answers, I'm just throwing all this out. So we can think about meaning and what? Intelligence.
This level of, just as a curiosity,
Yes.
this level of knowledge, is it, I mean, someone that wants to go entrance to AI, we hear a lot about AI.
Yes.
This level of knowledge, is it necessary?
I like it.
You understand my question?
Yes.
Because a lot of things are going on here, but we hear about AI,
Yes.
machine learning, and all those things, and we feel that everybody wants to enter into that area.
Yes.
Okay, but all these things you're saying,
Why is
is it necessary that everybody will go through this part, or is it a shortcut to...
No, believe you me, I see it as a shortcut, right? If I were in school and I had this lecture at my disposal, maybe I would have gone deeper into the biological sciences, honestly. But understand that there is a reason why. Okay, let us assume there is no reason. Students here and elsewhere are doing what? Using ChatGPT. But it cannot bear meaning. It is in short, richer, that I have a 1-minute conversation with Emeka, right? I am going away with the reality that the information came from what? Emeka. Who is what? An individual with experience, knowledge, right? Relationships and all. And I can always go back to contextualize what I got away or to relate it with what I have. But you know, when you ask ChatGPT, the funny thing is that I don't even understand what ChatGPT is. The thing is getting trained every minute. Your question is training it. I mean, what exactly, you're just dealing with a model that takes in code that comes out from other models and from other human beings. Now, behind its response, there is no meaning. Now, if I ask you what is the definition of meaning, what will you say? And if I tell you that, will you choose an inference that has meaning over an inference that doesn't have? Experiments have already happened when ChatGPT 4 was released. Professor Noam Chomsky is a professor of MIT in linguistics, asked ChatGPT 4 a moral question. He asked him, is it moral that humans terraform Mars? And the thing had the guts to say something. Do you get what I'm saying? Now, this is a question about morality. Is it moral for... Do you know what terraformation is?
No.
To put all those loops in Mars, because there's no oxygen in Mars, right? So we have to take material from here, fly all the way to Mars, build domes, oxygenate it, and then arrive ourselves to be breathing inside it. That will come at a great cost to materials on Earth now, not to talk about the energy footprint. So it's a moral question. Imagine your village, the entire village is going to turn into a mine, just to allow us to move 3 tons of terraforms to Mars. There are people that will be left in the village that will be orphaned now. So it's actually a moral question. But when ChatGPT 4 was asked this question, because Noam Chomsky coined this particular question with another professor when ChatGPT 4 was released, it was very funny that it actually had something to say. What's the meaning of what it said? I say it has no meaning.
So I have a question.
Go ahead.
So, in the course of your explanation,
Yes.
The affect space. So you said that it has hyperbolic time.
Yes, as we can see, there are separate natures of each, yes. Past, present, future.
So somewhat during the course of your lecture, it seems like as if the times occurring simultaneously. For instance, now you said that you give out a signal, and then everybody responds from the symbolic nature of what they had already understood in the past.
Yes.
But like in my mind, I was like, where did this come out from? For instance, you gave the signal, but I had no prior. I wasn't even thinking about it.
Yes, but it came out.
It just
Yes.
came out. So like somehow time is irrelevant when it enters into your affect space.
Okay, so I wouldn't choose irrelevant, I'll choose bent. And I'll prove it with one thing, goal and plan. Remember what we said inference was? The ability to make what? A prediction based on information available to you. Now, tomorrow is Sunday. Most people eat what?
Rice.
So generally, somehow you have a plan, goal and plan to do what? Eat lunch as rice tomorrow. If you are the one preparing and you will cook at a certain time, in this now you go to market. This is, you should think about what I'm saying. Has tomorrow come?
No.
Is there any empirical evidence or measure of tomorrow? It's just emergent, much less tomorrow afternoon. So you are picking a data point that is what? In the future. Now, something like that cannot represent itself as a training data set to any machine. Because the data set simply does what? Does not exist in what? In any. But it's so normal to us to make goals and plans. And as a matter of fact, modify our now based on what? Assumptions of the future. And equally, assumptions of the past. It implies that our own inference engine may be far more advanced than the machine. The machine, as we know, has no problem. The board is full, right? It has no problem from okay. Now, if we look at this, the 3 sides of this equilateral triangle, let's just assume this, right? Going from a repeated specific observation to a general law, what is that called? in inference. Those in engineering did it in Maths 111. Maths 111. Does it not exist?
Yes.
It still has that code. Yes. This is called induction. Is it not? Remember, you prove the case for 0, prove the case for 1, prove the case for 2, and then do what? Generalize to n. Engineering students, are you here? Is this not induction? Yes. Eh? What's it called? It's still induction. I agree. PMI, let's be clear on that. Okay, now, if you arrive at a general law in induction and you pass a parameter to it, for you to arrive at a general law, you have an equation of some sort, or an identity, or an inequality. You pass a number or a factor, an input to it, what do you now get? You get what? A specific result. This is called what? Deduction. Once you have a formula, you can deduce. Now, what's this last thing? To go from specific repeated observation to a specific result. What's it called? It's called transduction. That's machine learning. That's why the machine learns from data. This is data. Right? And when it learns that data, it has a model which it can use to do what? Make predictions. And yet, we can abduct. Sorry, we can retrodict. And we can what? Predict. So it looks that we, in our own inference capability, we suffer from transduction. A very simple way, I was gisting with a couple of gentlemen, and we're arguing on what it means for an object to be adjacent to another object. Right? And one of them says that for an object to be adjacent to another, it has to be opposite but deviated by an angle. I said no. That even adjacency is relative to your what? Origin. So the discourse went quite far. So a basic concept in geometry like adjacency, it is possible that the managing director of a bank can carry a wrong notion about it and operate functionally very well and successfully as a human being for over 35 years. Right? All the assumptions you have in your mind that are wrong can be referred to as what? Having been transduced. Okay? Then we have our what? Retrodiction, induction, abduction, deduction. Abduction is what paleontologists use in their study, or geologists. People that study past causes based on present effects. Right? The historical sciences uses abduction a lot. The experimental sciences uses deduction and induction a lot. And in our age now, we are using what? A lot of transduction from what? The machine learning. But have you just noticed that we seem to be the only ones that can pick data from the future and use it now? That's what I'm trying to say, right? Because of goal and plan, we can pick a data point from the future and use it now. Have you seen the nature of the hyperbola? That's what I mean. If our time were linear, we must wait to the future to do what? Make inference. Because again, all of the inference the machine makes, that is why all of it is what? Statistical inferencing. Okay? But a statistical distribution is not the only type of distribution, right? They are what? Probabilistic distributions, are they not? And they can take any kind of shape, Poisson, normal, binomial, and a lot more. But they are also credence distributions. Do you know that? Now, I've abandoned my lecture. You guys are quite interested. We are just coasting now. The credence distribution is belief. Credence is about what? Belief. Belief is nowhere represented as a data set. What will Arsenal and Man U play tomorrow? 4-4. That's why the world of betting exists, is it not? The Arsenal and Man U has paid a lot of matches for you to go and study the statistical signature of the outcomes. You can even come up with distributions, but you will still say what? Take a position about tomorrow. That's credence. Now, it doesn't mean that your credence distribution cannot come very close to a probabilistic one. Because if the probabilistic distribution is based upon the doctrines of chance, then it's not just a blind guess. It is a guess that is backed by what? Statistical support. And that is how the machine sees. It sees the future through what? The past. We create the past, and we can create the future we want, and we will use it in the inference. I don't think we're the same.
From what I've gotten, see that for something to have meaning,
Yes.
at least what I've gotten, for something to have meaning, it has to be able to experience what it's, or be able to visualize what it wants to happen.
Yes.
If something is getting the answers from other people's visualizations
Yes.
and other people's inferences,
Yes.
doesn't it also mean that that thing could have meaning?
Meaning. Okay.
Yes.
This is a very exciting thing. The lecture is what? Meaning and intelligence. I am not denying that the machine is intelligent. You can't go into the world making that kind of argument. Because there's an adjective before that intelligence. It's called what? Artificial. So nobody is telling you that we are grappling natural intelligence versus what? Artificial intelligence. But what do the two have in common? Inferencing. Right? Anything intelligent, you can only demonstrate it by what? Some kind of inferencing. Right? Whatever kind, but somehow. Right? Now, why is the ability to see through all of the inferences of others, right, not sufficient to classify your own inference as bearing meaning? Well, I like equations. I like to start with the fundamental ones. In any neural network, this is what you find between the links, is it not? Right? So, even at a fundamental mathematical level, the fact that you have linear equations, right, that adjust their weight based on data input and train themselves to now predict the test data set implies that there's something statistical going on. If there's nothing statistical going on, you will not train neural nets with training data sets. Right? Okay. Now, you can find a child who is not trained, ask them a question and they answer. And at times they can answer wisely or otherwise. But nonetheless, they do what? Answer. Somebody can also claim that the neural net does that too. The problem is actually in a very ancient debate that started in 1980 in Berkeley, right? Between John Searle in the Department of Philosophy in Stanford, in Berkeley, and the rest of the Ivy League schools. MIT, everybody was on fire. It's called what? The symbol grounding problem. So, putting it very slightly, it's in this lecture and I just cannot believe that I can continue sequentially, but I want to say just a quote of what John said. Okay, why is it necessary to point out the difference between the intelligence observed in organisms, right, and those of the machine? It is precisely because the intelligence of organisms is intimately connected to meaning, which we will demonstrate in this lecture is simply lacking in machines. In short, I dare say that for a machine to bear meaning, it is as unique, it has unique intentional states. Now, intention here is not I-N-T-E-T-I-O-N. It is I-N-T-E-N-S-I-O-N. It is a linguistic concept, right? Don't confuse it with like intention of people. Intentional states in linguistics is almost like what is represented by environment in as what? Completely jacketed by a Markovian blanket. You cannot see through intentional states. So on this ground, let us listen to what John C. replied, what he said. And we must remind ourselves, like John C. eloquently expressed, think hard for 1 minute about what will be necessary to establish that that hunk of metal on the wall over there had real beliefs. I say that Arsenal and Man U are playing 4-4. The person saying he believes it, at least to a degree. Some to a sufficient degree that, of course, they engage in the vice of betting. But I always tell people that that is pointless because you've not really studied probability theory. You see that there is no sense in betting, right? Because you will always lose. The people that create those odds create it for you to lose. So it's best to delete all the betting apps from your phone.
That one is difficult.
No, it's just logical. It may be difficult, but I mean, it's logical, right? It's a very logical thing to do. Yeah. Okay, so think hard for 1 minute about what would be necessary to establish that that hunk of metal on the wall over there had real beliefs. Beliefs with direction of feet, propositional content, and conditions of satisfaction. Beliefs that had the possibility of being strong beliefs or weak beliefs. Nervous, anxious, or secure beliefs, dogmatic, rational, or superstitious beliefs, blind faiths or hesitant cogitations, any kind of beliefs. The thermostat is not a candidate, right? Because at that time, what was being conflated was semiotics, if you ask me, right? You can't go from the electrical signals in the circuit of a machine, right? And somehow jump into the interpretative space of symbols, right? If two people here bear the name Chinedu, and I just emit the signal Chinedu, two of them believe that I'm calling their name, right? One person's Chinedu is no more the same, other person's what? Chinedu, even though the signal is what? Identical in the joint world. This is what we are talking about. To the machine, all Chinedus are Chinedu. Unless you add one more vector, right? To distinguish, and then you add another vector, add another vector, add another. That's why the entire world of machine learning is filled with what? Transposition of very huge matrices, right? You want to be good at it, you just have to be good at matrices and their transformation. So what is underneath this is statistical. It's linear equations, right? And there is just no way of jumping from that into what a belief is. Because a belief is a ground of meaning, one of the 6. Desire is another ground. Values are another ground. Culture is another ground. Knowledge is another ground. Obligation is another ground. You took a loan from a bank and you pay what? 30,000 every month. That's an obligation. There's no way the machine can understand the import of that. And if we didn't have real beliefs, why do April Fool work? And somebody tells you something and then your mind skips. Then the person tells you April Fool, your mind relaxes. Is it not so? So that is really because information affects us. It does not affect the machine. Right? Imagine you're living in a community like some of our brothers in maybe Gaza, and then you hear that, man, they are going to bomb our area tomorrow. Everybody run away. Do you understand? Merely hearing that and you really being in that, your heart will be what? Racing, you pick the things that are necessary, start calling brothers and sisters, and then bail. Right? Yeah, that's the sense in which information affects us. And if you check it, if you were there with a robotic AI, there's nothing stopping the AI from telling you, chill now, we can wait out the bomb. Yeah, you look at it, it's made of metal, right? The fire is not going to pain it, the pressure, nothing. The blast sound, shock waves, all of those. In fact, if the whole structure crumbles, it does what? It just enters into another form and continues to remember whatever it claims it remembers, right? So we are distinguishing using this model that there is a whole unrepresentable world in training data sets. That's what we're calling the private world. If anybody could come up with a training data set of itching, then the ChatGPT would truly understand what itching is. But even if you were to represent it as a training data set, you have reduced it to the world of what? Signals. And that reduction, I tell you, is massive information loss. In fact, I can even happily say, take this away. Take this away in this lecture. If everything has sounded so compliant, no, there's a lot going in. Take this away. With respect to language, this is the map. This is the what? Territory. So meaning is the territory. And your speech is what? The map. Go ahead. I'll give him.
Right. So I actually have two questions, but the second question just came after the statement you just made now.
Yes.
So you are talking about the losses that come about by reducing something to a signal.
Yes.
So my question now basically is that what's your assertion?
Yes.
Is it that you want to bring in something else newly to describe what information could be in the body in terms of like itching? Because for the psychologist, actually, every single thing is a signal. Or what if you take it like, for example, say, what is it in mathematics? This thing that has multiple sine waves that we saw. Fourier transform, exactly. So, like, what if you take it that signals have, like, limited signals basically have information that we cannot actually catch. So, do we entirely kick out the terminology signal and bring something newly, or? Yeah, so,
Okay. I used to think this one until I entered the amazing world of biology. No, we will stay with the signal. And I'll give you one example. When you breathe out, what do you breathe out?
Carbon dioxide.
CO2 plus other gases, believe me. If you measure it, you see that it's not that uniform, okay? Now, the CO2 is taken by the trees, right? And then what they exchange outwards, we breathe in, right? As oxygen. Okay. Why am I sticking with signal? Because all mammals also exude butyric acid when they breathe out. And there's a particular insect that listens for the signal of butyric acid. And that insect is blind. And it doesn't hear. It's called a tick. So the tick stays at the blade tip of grass, waiting for only one signal in its cold, dark world. When a mammal is passing, breathes out, it picks butyric acid, which is completely scentless to every mammal. And then it knows its prey is close. It falls to the body of the mammal. Then the next signal is heat, feels the what? Temperature, burrows its way to a smooth skin, puts in its proboscis, sucks itself through the blood, falls to the ground, lays its eggs, and dies. It can wait for 12 years to do this. Welcome to the world of biology. You know, engineering students, we think we are smart. You should go and check the biologists and what they are dealing with. Now, if every single mammal is completely oblivious to the butyric acid, and that is for the tick, what? Light. You know, when the sun rises, that light you see because of your eyes, that is how the light is in the what? Umwelt of the butyric acid. Umwelt was termed by Joseph von Uxwell. It means the dwelling shell. So it implies that different organisms are in different dwelling shells in the what? In the joint world. Do you think that the butterfly sees the sky the way you do?
No.
Even by the laws of physics, and we know by the laws of optics, if you begin to look at the dimension of the eyes of organisms, you come up with different what? Shapes. I don't know of the material of the biology or the biochemistry of the optics. One factor could be what? Nervous connections. Okay? The more nervous connections in an organ, the more sensory possibility. Right? And the nerve connections of the eye are two ways. Sensitive to light and also good for what? Motor function. We can keep our head fixed and look like this. And yet our forward visual plane is so poor compared to that of the ego, which almost has what? 270 degrees, looking this way. So the F-35 jet fighters, those pilots can see what? 270 degrees, right? It's almost 360. That's the ego's own wealth. In the thick stone is blind, but butyric acid is light. If all organisms bear meaning, they are not in the same dwelling world. Right? And let's take the Ichneumon wasp. The Ichneumon wasp can pierce the oak with its ovipositor. Right? You know the oak tree? It's a tree. It's very strong. I mean, you need an axe to bring it down. But the Ichneumon wasp will just pierce it, get into the lava in there, right? That eats up the oak from the inside and then sucks, that's the food, its food. If it's passing and there's lava there, how it sees it is its own what? Own wealth. Its dwelling shell. So don't underestimate signals. The fact that a signal is not present in your dwelling world does not mean it's not present in another organisms. And this will lead us to what? An explosion of what? Signals. Even signal of the same form, let's say light, right? Is in what? Bands, spectrum. There's a region called visible light. And after that, you get into another region, right? And then you continue until you meet what? Planck's constant, which is the what? Limit of length in quantum physics. Right? There are some animals' own wealth that they do not even take any particular physical state of affairs, but they take what? Motion. Right? There are some animals that see because motion has happened. Right? If things are still, it's not seeing anything. When things move, right? All of us has been driven by a mosquito. We try to kill it by the hand, right? The mosquito flies very asymmetrically. And before you know it, it can just perch in your back. Okay? So, different animals' own wealth, right, implies different dwelling shells and implies different regions of different signals. When the bat emits that sound, all of us used to call sonar, that the bat flies at night, right? And then it emits that, it hits the wall and comes back for it to see, right? Don't forget that that sound is also like the worst sound for the moth, the black moth, which is the primary food that the bat eats. So if you begin to go into the foray of worlds in biology, you will begin to see that there is a kind of balance and deep order. A kind of co-principle that is connecting different organisms, all of them semantic machines, because they make inferences, feeding, survival, movement, right? You put something to an insect crawling, it will just turn left. Is that not inference? If you are to bring a mechanical machine and write a program that makes it to turn left upon meeting an object, you will sweat over that code, I promise you. That's what's studied in robotics. Right? And you won't begin to see the grace and ease or the complexity of the algorithms that some of these organisms use to express it until you try to do what? Replicate it on your own. Okay? And even at that, there's a lot of losses. So to cap this particular section, I want to represent that with respect to language. You can imagine what I'm saying is the map. What you are understanding is what? The territory. If you take Google Map and look at it, it can tell you the direction to what Cheat is, right? But if you look at that Google Map in this now, it can never tell you what is happening inside Cheat now. The territory and the map is not the same. But if I'm just to ask you casually, between the territory and the map, which one has more information? Exactly. The territory. The territory, yeah, you say the map. Okay, let's prove it. Google map on your phone. It has more information than what's an example of a territory?
I don't even know.
This building is a territory. If you look at the map, will you find this building? Exactly. So which one has more information?
You can't. Google Map is
It's logical, right? Yes.
I wanted to ask.
Yes.
Okay. So from your presentation so far, you've made a lot of references to biology.
Yes.
And you studied some biology because you are fascinated. Okay?
Yes, sir.
And I remember when I was in my MSc,
Yes.
I was trying to automate timetables, timetable generation, and I hit a wall because I was using the brute force. And I realized that my computer will be on for days,
Yes.
and it has not yet found the timetable that will be optimal. So I now started researching how do people make timetables automated. So I now entered into the world of genetic algorithms. That was then. And that's what they do there is that they observe biology. Okay, they observe the way the DNA functions, and they try to use it in timetabling, the computer field. Now, I want to ask this AI, machine learning. You've been talking a lot about biology. Is it that a lot of things are borrowed from biology?
Yeah, well, that goes without saying. Even biomimicry already, as you well see, is copying biology from the what? From the physical representation, right, of robots. Okay, biomimicry is to look at nature and try to make the mechanistic version of an organism, right? And it has brought in progress in so many technologies that we even see, like the jet fighters or do you understand? At times, like I tell you, the F-36 own visual frame was borrowed from the visual frame of an eagle, right? Exactly. So, and yes, a lot is borrowed from biology. As it pertains to this lecture and what we are saying, one of the most complex information is biological information. Biological information was discovered conclusively in 1953 by Crick's, James and Crick's, which is the DNA, what we call the DNA. And I have a little quiz, maybe 1,000 naira, whoever gets it. Yes. How many alphabets does the English language have?
26.
Who said one? Ah, you got it. Please, a round of applause for it. Yeah. No, you have seen how transduction works. Remember I told you somebody carried the wrong idea of adjacency for 30 years. Now all of you are in graduate school and you are carrying the wrong idea of an alphabet. That's a transduction. Yes, we are getting there now. We are getting there. We are getting there. So the English language has one alphabet, and the alphabet has 26 letters.
Oh Lord.
So the letters of an alphabet and an alphabet don't mean the same thing. So you've always carried this transduction that English has 26 alphabets. If you see 26 alphabets, each having different letters, you'll be confused. That's a lot of symbolic space, right? Mathematics is an alphabet, is it not? It's an alphabet of quantities, numbers, right? And it has many letters. Remember this, you remember, right? Okay? It's a formal language. Music also has what? An alphabet. Represented by different scores. Right? You see the melodious and harmonious scores. Go to those in music. Check those sheets that they read. Right? So you're beginning to see that the alphabet upon a language is a representation. A formal representation of the language. Right? And what is the alphabet of the machine? Just 0 and 1. And it's amazing how you'll be chatting with 0 and 1. Yeah, I'm just joking. Right, but it is 0 and 1. Everything is reducible to what? Those two states of binary regime, right? Okay. So we are following, we deviated a bit to make reference to what? Biological information. How many alphabets do you think the DNA has?
One alphabet.
Okay, now you know, right? You know. But so far as we have seen, at least so far as I have seen, and you need to make reference to some of your professors in biochemistry and colleagues too. I first of all isolate one. A, C, G, T. Now, this is the alphabet of the DNA storage. How the biological information is stored in that crystal. Because DNA is a very hard molecule. And it's three-dimensional, very small, right? It is in 1,000 trillion cells of your body. So it's a distributed information system that is distributed 1,000 trillion ways. No, I tell you this because in the real world, I have designed and built distributed systems. Distributed systems are take-down resistance. If I place one in this data center, place this one in this data center, and this data center maybe gets destroyed because of natural disaster, like earthquake, this one will be in operation. And this happens to you. Is it not logical that you lose a lot of skin cells every day? Do you know that?
Yes.
Exactly. And each of those skin cells also carry the DNA. But you keep functioning. You persist as if nothing happens. Right? So the DNA is distributed information. First alphabet in storage is this. But when it is time for protein synthesis, when it is time for you to grow, a part of your body to grow, when it is time for biochemical reactions to take place in your body, then you need proteins. To copy this alphabet, it uses another alphabet. A, C, G, U. Thiamine is dropped in favor of uracil, and this is the mRNA. Now, from this mRNA, this strand of the required protein that your cell needs, or the required proteins that your cell needs, how the mRNA gets to know the proteins that your cell needs, I don't know. How it gets to know the section of the DNA that has to unwrap for it to copy it, because it is a double helix, right? It is folded. How it knows the one that has to unwrap for it to copy, I don't know. Why it is substituting thiamine for uracil, I don't know. But I can observe as an electronic engineer that there's a second alphabet here. From here, it goes into the ribosome. And then there is a process of translation where the sequence of the mRNA begins to translate into the 20 amino acids that code for life. And yet, they must come in triplets. So these codes go into the what? Third alphabet. So, 1. Okay, yeah. Right? And, well, we like mind maps like this. It gets more confusing, but yes, we can wipe it, please. Right? Yes, we do. Okay? We go with what? The third, which is what? Codons. And these codons are degenerate. A degenerate code is a code that has repetition. As you know from the mathematical theory of information, that the redundancy, which is the basis of all of your cryptography, is 1 minus relative entropy divided by maximum entropy. English has a redundancy of like 50%. That means 50% of the possible things you would have ever said in your life are not said because you're speaking English. They are unsaid. The language has constrained you. Different languages have different redundancies. Exactly. This is a very good experiment. It is good that you use the Igbo alphabet or the Yoruba or Hausa alphabet and then compute what? The redundancy in the language using frequency analysis and the dictionary of words. you will need a dictionary before you can perform this experiment. A dictionary is a collection of definitions, is not?
Yeah.
For a particular language. Now, these codons, for instance, just for demonstrative purpose, you can have ACC, ACU, AUG. And these things can serve for the degeneracies of leucine, which is an amino acid. That means if he sees this, it brings leucine. If he sees this, it will bring leucine, right? If he sees this, it will bring leucine. So, 20 amino acids, we're in what? Fourth alphabet. And then by the time the amino acids come together to form a peptide chain, right? What we call the polypeptide, right? Yeah. You now have a protein. But it doesn't end there. A polypeptide is a particular kind of protein. Example what? Histone. And then that protein does what? Folds in 3 dimensions. The fold logic, right, gives you what? Something that looks like this. And this is functional complexity. That is specified or specified functional complexity. 5. As far as I know, 1, 2, 3, 4, 5, 6. 6 alphabets work together to do what? Produce one enzyme which catalyzes biochemical processes in your life that allows you to breathe every moment. Now, that's not the kind of coding we do in engineering, is it? This is serious, because it's biology. But the point here is that, from what Emeka said, that the whole science just ends in biology, right? The complexity there is, everything there is non-linear. You are very happy with your first order differential equations, right? It's first order, or linear algebra, right? You just like to deal with x. When x squares itself, you are losing information. When x cubes itself, you are losing further information. Because it implies that you are having intersection, right? Okay? The space of simultaneity is the space of lost information. Signals can't see through. When a signal reads this data point, it will not know that it has happened 3 times or n times in a specific spot. Right? This is information loss. Remember, signals can take what is what? Distinct. It has to distinguish states and then bring it back to codes. Right? If you have a 4 digits, okay, what do you have? 2 raised power 4, is it not? If it's binary. This can take 2 states, right? This can take 2 states. This can take 2 states. So if you combine it, you arrive at 2 raised power 4. Or in general, 2 raised power n, where your n is what? The number of digits of your bits. Or number of digits of your, or degrees of freedom, as it's called. We are saying this because the reality of machine learning is what? The reality of signals. And the reality of cause and effect in biology is still signals. But how all of these things just gravitates into the symbolic space of interpretation and understanding, right? Is the magic that I'm here to separate. And to further prove it, you just can't get the data set from what? The empirical affect space. If you could, we'll be having data sets of what? Itching, right? Hunger, pain. I'm hungry. Really? Like hungry. Do you hear this kind of thing? Do you understand? So nobody just knows. In linguistics, it's called modification, degree, right? Something is true to a degree. Those kind of things are. In fact, I like in mathematics. Do you know what they are called? Pathological functions. Pathology means what? Disease. Right? Diseased functions. That means they are not well behaved. Maths like what? Very nice, well behaved function, right? Okay? Like your, what's this logistic? You know the sigmoid? Have you seen the sigmoid that is used in training or normalizing, right? Very well behaved, or relu, rectified, you know? All those very nice behavior. But in the real world, in the joint world, you are going to see functions that are continuous everywhere and nowhere what? Differentiable. You can't differentiate it. If you take any point here and open it further, you start seeing something like this. Then if you take this point, open it again, you start seeing, yeah? So it's almost like it fills space that you must take a position, encode it, and then leave the rest to be what? Lost. That's information loss. Go ahead.
Well, sir, this kind of graph,
Yes.
you can model it.
Already, it's been done. These are called the equations of Sir-Waitress. It's called the Waitress function.
Yeah.
It's in trigonometry. Right? The fact that maths can model it does not mean they know what to do with it. It's pathological. I mean, if you use it, you must lose information because it has a scale at every depth. That's more like what a fractal does. Every level you enter, you see something. You see, the territory is very large. Remember? You open a door, you see something within the territory, right? Different from what you see if you open another door. But if you look at the map, maybe that territory, a building, is represented with what? A dot. And they call it what? Cheaties. And it will remain a dot in that map to help you with only the dimension of direction. But on a day, 29th March, across 24 hours, there is a lot of events going on what? Inside the point. My point is that that information is what? Lost or not representable to the machine.
Sir, please,
Yes.
you know what they taught us that, like, if you observe the sequence, you can predict a exact solution of it, especially when it's converged. So this thing you are saying it will lose.
Yes.
What if you look at a good adventure based on this converging
Series, yes.
you can get that lost.
No, it's very good. That is what is called a Cauchy sequence.
Yeah.
Right? Especially those sequences that can converge or some sequences that diverge. But at the end of the day, for me, a sequence diverging or a sequence converging, you are still dealing with numbers. In the real world, those things are symbolic. If you are measuring, if I give you a temperature series, right, and obscure the body, if I give you 17,000 different temperature series, right? A1, A2, A3 down to A17. And each of the series has what? 100,000 entries. I give it to you, you go into your equations, your models, and then you flow. But the moment I tell you that this is the temperature of patients in a hospital, then you realize that those ones that you saw that maybe went to 54 degrees centigrade, right, and went down will represent the patients that have died. But if I tell you that it is the temperature series for a hot metal within different factories, it won't matter. Have you seen it? So when those numbers now come to light, you've entered the symbolic space, and normally happens in AES. That's the territory. That's where the action is. And it's only in the world of biology that I've seen such type of actions. It's just not in statistical mechanics. As far as I can see. Yes.
My question is basically based on that scaling thing you talked about.
Yes.
Going into one information.
Yes.
So I think about it in the past, because I thought that probably laser will lead into kind of infinite way, like the more we keep going,
Yes.
an hour for we see different information.
Yes.
But then now after talking about DNA, and we're going to have a meeting, given that since the whole DNA of an organism boils to that first alphabet, A, C, G, T, and it stems to bring out every single thing that exists. I'm going to have a meeting that probably isn't that going to be one final skill that exists that we can able to map out all this information, like we need to collect all this data.
Yes, this is very profound, and I tell you that's why genetic information is like hot cake now, right? Because even I didn't even transcend after the protein to now talk about genes, right? And their expression, right? So you still have to get to the level of the gene, okay? Two different organisms can have two different genes for metabolism. So one eats 7 wraps of apple, and tomorrow he's good and fine. Because his metabolism just scatters the whole food in a very fast rate. Yes, you know people like that. And then you see another one that after the 7 pieces of apple, is demobilized for 3 days. Right? So different metabolism for different, right? So it's all in the genes. Then you see another person, he enters into the gym. 2 months later, the muscles are as big as your head. And then you see another one, 1 year, so, you know, right, so what, genes, okay? So I'm saying that from the proteins, you still have to have one more to the genes, and that gives the diversity of all the different life forms for which we have not even finished or started mapping the oceans, right? If you look at the mass of oceans, they are much more than land, right? And yet, they are different kinds of, yes, okay, let's go ahead.
That actually brings me to the question I talked about earlier.
Yes.
Because it now brings us to when we are talking about nature or biology
Yes.
and machine, basically,
Yes.
as it relates to intelligence and meaning. So at some point when we were talking about how we learn, we were talking about transduction and
Yes.
all that.
Yes.
Now, there's another thing that, okay, does it actually points out that or it actually points out that we and machines are different, because even when you give the example of the fact that we see the world from historical perspective, they see the future from the past.
Yeah.
How we carry the future and more like
Exactly.
the past. So my question is that is it possible for us to work together, or is it like does this entail scrapping them?
No. So we cannot remove all the good things that the machine learning has brought. For instance, in the world of radiology, you even have it interpreting some of the scans better than very experienced doctors. Remember that some of these training data sets that are fed into machine models are training data sets that are supervised learning under experts. Right? You have experts in silvology, you have another expert in radiology, you have an expert in mathematics, and they do what? Either prepare supervised training data sets or unsupervised training data set, and then the models, different models, learn on the same data set, and the most optimal model does what? Is chosen for the industry, right? These things bring out the good. But we have to also take it further. Just like every technology, you see the unethical side of it and the ethical side of it. My problem comes when I'm going to circulate this lecture because it's very clear to me now that we can't read it through, right? So it may come in for your further reading. Where I'm going with this is that the machine, the interaction of the organism and the machine is, for me, what is paramount. Because that takes us to the world of pragmatics. Okay? If you were born in this year, or let's say if you were born in COVID, you are 5 years old, right? Today. And if you were 3 years into your awareness of Earth, you saw smartphone. And that smartphone has constant data and you were left with it. You would naturally just drift into apps like what? TikTok. You know this app? Now, what the baby will not in 100 days or even 10 years, be able, even 15 years, be able to tell is that by moving from one short video to the next, you are bringing to the surface of your attention the rapid shifting of your external environment at an unnatural rate. If you see something funny, you laugh. When you laugh, you have a dopamine hike in your brain. If you see something unfortunate, you feel bad. Then you have a dopamine low. And that high and low and high and low and high and low are hormones. Hormones are proteins. They are not fun. You are getting to biochemistry. Done long enough, what do you think will happen to your brain? You are not going to be able to pay attention to anything for long. You have attention deficit disorder. For 7 years, I've been using this phone. Precisely because of this. 7. This is the 7th year. It is not necessary or compulsory that you do this, but it's to also show you that this is serious. Let us ask why. Of the 6 parts of your cognition, which one is the gateway to your brain?
Perception.
It's your attention. Because you can be here and pay attention to what? Your official version as a governor. Oh. Right. It can be a counterfactual, it can be a conditional, right? But we do these things. Mind models. Okay. What's the gateway to your attention? Your eyes. That was why what? That first experiment of what? Closing your eyes, shut down. Go ahead.
The ears.
The ears.
Most people, for some people.
Yes. I mean, again, you see, I like that ears for some people, given that we are dealing with what? The affect space. Some people's ears are so sensitive, right, that they hear what you don't hear. Others' eyes so sensitive that they do what? See what you don't see. But others' nose, like, yes, go ahead. Eh? The 5 senses are the gateways. Yes, so I'm saying that they are all gateways at relative capacity. That the last gate man is the eyes, which is why what is in your visual field almost always seizes your thoughts. Not always, right? You can have people that they dream, or you'll be telling the person gist. You'll be saying, he just wants you to finish. Just thinking about, right, where next. So, but most times, what is in your visual field dominates, right, your thought. Now, when you now have very fast-moving video, remember that in the natural scene, the natural processes have a natural rate. If trees are flowing because of the wind, right, there's a kind of speed that is natural. If an insect passes, I mean, there's a speed a car will use to run past you. You know that an event that is abnormal has happened. Yes, like if a car passes you with the speed of a grasshopper, there's a problem. Right? So somehow we just carry around in our mind, somewhere in the background, how the natural flow of things are. Now, if you put a televisual experience in front of you and you keep, right, going, something very interesting would happen to you, and I'll tell you. Something will happen in your now, in that hyperbolic time, that will make 1 hour look like what? 4 minutes. And time will just miss. Now, why have all of you confirmed this without expressly stating it? It is a fact, right? Psychologists were also part of the app design team for TikTok. It was designed to keep you what? Fixed. It was not designed for you to look away. Are you getting that? So it is important. It is important that now recent psychologists are now saying that the smartphone is an experience blocker for children. Yeah, that's the word being used. Experience blocker. And think about it. How many of you climbed trees when you were young? He's ready to exactly. Some of us used to live in the tree during mango season. We had friends that broke their legs, broke their hands, right? Exactly. So by the time you have more generations having less interaction with the external world, you are having generations that have less experience with nature. Where are your botanists going to come from? Exactly.
From school.
Right? Because the botanists will be looking at the flowers without understanding the smell. In the televisual experience, it will only come with sound and what? Visuals, right? You lose smell, you lose vibration, and then you lose what? Taste, okay? And it is also why in society, you are beginning to see people have an accident, and other people bring out the phone. And there's nothing funny about this, because you knew from your affect now that that person is on the floor dying. And twice I've been in that occasion, and it was actually my intervention that put the person in a taxi to move to the hospital. Twice. And in these 2 times, people brought out the smartphone. Just like I said, twinkle, twinkle, little star. An accident happens, they bring out the smartphone. I caught it on camera, I caught it on video. Right? But you should also understand that it is the greater loss of the affect space and a kind of conditioning. Do you remember Pavlov's experiment, where he rang the bell and they brought food, rang the bell, brought food, rang the bell, and then when he didn't bring the food, rang it, the dog started salivating. It's conditioned reflex. It's very old. Anything you repeat conditions your brain. And today, if you're spending 8 hours on the phone, I don't see why you're not a cyborg. Yes.
Actually, very agree with what you said. When you think about this process, so one of the things that I'm going to see like the digital things for me, or the visual things, was one of the things that enhanced my creative ability or my imaginative ability.
Yes.
But being coffined in a place where you are just limited to what you see, I believe that it affects how you imagine.
Yes.
Even when you are imagining things, there's certain kind of pictures you cannot see. So I kind of felt like, okay, having access to things like this
helps.
They broaden your horizon.
And so, you are perfect. You are completely right. Right? It's just like saying, is eating food necessary or good for you? Does it keep you healthy?
Yes.
Yes, and it gives you energy, right?
Yes.
Okay. That is food, right? Now, what if I add an adjective here in front of the food? What will you get to?
Fast
you can
food.
also have what? Junk, fast, preserved, natural,
raw,
processed. Have you seen? It continues going. And each adjective modifies the word. Now, giving you new meanings. So, food is good, but it depends on the adjective. Content in the internet is good, but it depends on what?
The content.
The content. So, the individual who goes in there for research, for very good purposes, good goals, would inherit a lot, because it's like a library of libraries. There's a lot of information there that can really allow you excel. And also, in the same vein, to the left, and I will be closing with one remark. Emeka would have this lecture in print so that you can have access to it, right? And there's just one thing I want to read for you. This came from the Mathematical Theory of Information Communication, 1948, Shannon and Weaver. This particular section of the article was written by Mr. Weaver himself. And I said, one of the motivations into my personal journey with meaning is what I term Shannon's arrogance in that article. What Shannon said is that he brought 3 levels. Level A is the technical problem, which is the problem of conveying information from one physical point in the world to what? Another, which, as you know, is what the internet is doing. I mean, the content you are seeing in your phone is in some data center somewhere, right? And then it follows waves and comes to your own physical location. So, which paraphrases the central dogma of information theory. And it says that meaning is irrelevant to the technical problem. So it's saying that the semantic problem, which is making sense of the information that arrives at the destination, is irrelevant to the theory of mathematical information communication. right? And so far, if you look at how the internet has progressed, how Shannon's own article gave us cryptography, it's really been an excellent, and it was his master's thesis, right? It has really, really been an excellent contribution. It's the bedrock of internet communication. So there's every reason why to believe what is said there. But I said no, just because of that statement that the semantic problem has no engineering relevance. And that was 1948. Shannon died, I think, early 2000. And then we're in 2025. We'll read still what Mr. Weaver said then, and then compare it to what is happening now. Okay? So, and I said, and we know Shannon is no more with us. But the after effects, remember the after effects space? Yes. The after effects of his assumptions are pervasive today. Misinformation and disinformation are everywhere in the internet. Right? Okay? And since the internet is to send information from source to destination in the manner so described, this is what Mr. Weaver said at that time. An engineering communication theory is just like a very proper and discreet girl accepting your telegram. She pays no attention to the meaning, whether it be sad or joyous or embarrassing. But she must be prepared to deal with all that come to her desk. This idea that a communication system ought to try to deal with all possible messages, and that the intelligent way to try is to base design on the statistical character of the source. That is why the entire ChatGPT, the always Markovian processes that are under the subset of ergodic processes. An ergodic process is one that the sample space is equal to the universal space. That the sample average is equal to the space average. That's an ergodic source. An example of an ergodic source is what? The English alphabet. The probability that what I am saying is going to be pleasant to your... Why did you say yes? It was not part of my signal. Because the alphabet is ergodic. You predicted yes. High five. It's good to confirm theories, is it not? So an ergodic, that's exactly how ChatGPT works. Right? It rates what you are likely to say in the next word, next phrase, next sentence, right? And then spits it out for you in the prompt. So it's an ergodic process. So that's why they said it should be based on the what? Statistical what? The statistical character of the source is surely not without significance for communication in general. Language must be designed or developed with a view to the total of things that man may wish to say, but not being able to accomplish everything. It too should do as well as possible, as often as possible. That is to say, it too should deal with its task statistically. So when I tell you that machine learning is a statistical technology, the fathers of the entire space have already emphasized it twice. But we now know that with credence, goal and plan, hyperbolic time, even dreams. A dream is a low probability event that can have high consequence. You can have one dream and remember it for the rest of your life. But the probability that that is the dream you are supposed to have that night, and that's the one that will make an impression on you for the rest of it is just low. In fact, there is no space like the space of dreams. One of my friends told me, have you noticed you never see your leg in the dream? I said it's true. You understand? I mean, but everybody will come and be gisting in the dream as if they were standing up or that there was gravitational field. No. Right? It's after the after effect space, right? These are some of the training data that just cannot be represented to any machine, right? Now, my own conclusion is that, and yet today, the internet is filled with what? Censorship. If truly the meaning of the message was what? Irrelevant, why is the internet being censored? Do you know that there are some content you can't get from certain European countries because your IP address is Africa? Yeah. That is outright discrimination based on geography. Right? Okay? And then you can come out with the truth about your society, right? And your local government does what? No, 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 you're not publishing this. Right? The internet has been censored. Okay? Even if we leave the division between the dark net, which is the part of the internet that is dark, and the rest, which is in the light, that's already a natural division that happened a long time ago. Okay? And then, while governments can censor social media, discuss within their own nations, we are not interested in the specific censorship phenomena in any nation or the origin of deep fakes from AI. AI is producing faces of 65-year-old people that never lived. Have you heard of deep fakes?
Yeah.
Exactly. So all I need to do to transduce information is to generate the face of a 65-year-old journalist that never lived, put it in front of an article generated by ChatGPT, push it out, then you read it and you go argue with your friends. Have you seen the problem of meaning? Right? That information has no provenance, but it passes through your experience. You take it as knowledge, right? You add it to your priors. It modifies your assumptions about the world. And then you argue from that perspective, something that was just originated statistically from nothing. Come on, guys, sound somehow. Right? So what Shannon and Weaver assumed has broken down in this age. You can't say that a communication theory should not consider the information content. After all, information content is functional, specified functional information. Specified functional information is still information that comes from a space, like an alphabet, but that has a functional specificity. That is doing something. If I tell you come, it means I actually want you to what? Come, because I have needs. The machine has no needs. It doesn't sleep. It doesn't need to sleep. In short, it doesn't care. Now, imagine getting information or exchanging information from a semantic source that does not care. Right?
But it can be programmed to have an emotion or to replicate in a way it care. It can be programmed to do that.
The question is whether the replication of care and care itself are the same. Under what grounds? Remember that I have claimed that meaning only exists in biology. So all I'm saying is that the entire emotional import is just given to biological organisms that have affect. So if you bring mechanism, right, circuits with electrical signals traveling in wire, it becomes very, very difficult to tell me how a cell, which also reacts, by the way, a cell can react to acidic conditions around it. Maybe a cell is optimal when the pH level is 7, like water, and when it goes acidic, it recoils. Do you understand? Or begins to produce certain proteins, right? And their biosemiotics is the study of the sign exchange between what? Cellular processes. Do you understand? So the action that is happening in biology is not joke. Remember, every cell wants to be alive. If large enough cells in your body die, you as an organism dies. In short, if large enough cells in a particular organ die, you are fried. So it's not joke. But the AI can joke. It can afford to joke. It's made of metal and electricity. One question before this. Yes.
The only way to quantify meaning is through by biological means.
Well, this will be my own submission. My own humble submission.
Now, my idea is that if the only way to quantify meaning is by biological means, then why are we bothered with machine learning instead of putting that effort into improving humans' own capability of learning?
Yes. Okay. This is a very germane question because this is the kind of logical conclusions we should be reaching in this kind of lecture, right? Or discussion. We are better than the machine in recognizing, but it is better and faster than us in computation. So it's a trade-off. So it's almost like give to one what you are better than, right? But also recognize what you are better in. Right? Okay. Come again.
So what I'm going to
Yes.
modifying your own human experience.
Yes.
So if you can quantify, human being can quantify what meaning things are.
Mm.
It means that in a much greater aspect, when it interacts with the normal world, it understands what it's doing. So now, if you are able to use machine to now improve on human own, maybe like how we talk about data sets now.
Yes.
The mind is the greater data set than any data set.
Yes.
Now you can even improve the own mental data set using machines now. Human beings now become even better. For instance, now this thing of that gene editing.
Very dangerous. CRISPR, right? You've heard of it?
Yes. So if you're able to edit people's genes to be like higher human beings, then you're not enter the space of like you like someone that is normal now needs to us now, and then somebody that was genetically engineered to be better than everybody.
Okay, I see where you're going. This is the works of Jennifer Doudna, the clustered interspace cellular palindromic repeats. It's almost like a scissors for genetic information to cut and join somewhere. Now, it's not very clear to me that cutting and joining biological information that is billions of years, right, would lead you to a better outcome than you already are in, right? Part of the reasons why I'm saying is even you even have the ethical questions to deal with, right?
Yeah.
They always come with the pretext of syndromes of children that are born and how those kind of gene editing tech could help them and their chances of survival. But if you break through in one, you open up a what? Another camp, because I'm even hearing that this CRISPR with the DNA of dinosaurs can bring those dinosaurs back. I don't think we are going to be happy if dinosaurs just run across Osuga. Do you understand? So, well, we don't know. I don't know, me as an engineer, but one thing I think is that the dwelling shell of organisms in nature, respecting the laws of nature, is the best equilibrium you can get to, right? So it's almost like we are trying to solve a problem that has been solved so perfectly well, right? It's almost like when you touch it, you spoil it. So if you are saying that, hey, there's a syndrome for babies which you want to cure with CRISPR technology, maybe the 8th generation back of what the parents were eating led to that syndrome in the baby. Right? Yeah. And if that hadn't happened, maybe the syndrome will happen. But because of the syndrome, you come to cut genes. And in cutting genes, do you understand? It's almost like in engineering, once you solve a problem that has a quantity X and create other problems that has a quantity Y, and you find out that Y is greater than X, in some cases, Y is even greater than X, you created more problems. Right? So I think from a quantitative perspective, this is how we have to look at it. But going back to what you said about will this make us better versus, I think the machine has everything to learn from us. We designed it, right? It was Fisher that brought out the theories of statistics and put it on solid ground. It was Kolmogorov that axiomatized probability theory. And with statistics and probability, you've captured the whole world of machine learning. And these things were done years ago, right? It's just that computational mechanisms have now allowed the statistical principle to be applied to data, right? Raw data. If you capture data with sensors, you put the right machine model on it, supervised or unsupervised, it will learn something, and begin to make predictions. So that's the age you're in. So I don't think nothing special has happened. And there's also a lot of hype around AI, okay? But we can't also forget the data sets you can't touch, which is what the lecture has shown us. We can't also forget that we pick data points from the future because maybe in our affect space we work with hyperbolic, but we are time binders. Human beings seem to be the only organisms that can plan what will happen next week, and you see that thing happen in W1. Goats don't seem to. Have you seen a community of goats having a meeting? Even if they do, we won't know. So that's the funny thing. Maybe there's a way they do their meetings, but we just won't know. Okay? So maybe we have a lot to show, and also more importantly, maybe we have a lot to learn about ourselves. Because one thing I can say is that if you agree that the EAS is the territory, right? And that the EES, W1, map, right? then it implies that all objects, that's why there was a dot there represented as an object. And you saw the functional cycles there. That thing came from what is called active inference theory. You guys can look up active inference. It's making a lot of waves in robotics. Now, this object, which is external to your ES, is also part of the map. Now, if you spend 8 hours there, right? You're spending 8 hours looking at the map. But what about spending some time in the territory? So at best, it may start showing us that we are getting to that time when we have to be a bit more introspective, look more into our minds, right? Understand ourselves better, and also learn to practice meditation. Maybe that is what this time is teaching us. Because already we over-intentionalize, right? And under-extensionalize. These are semantic concepts. So if you come and tell somebody, please go to ShopRite and buy me bread. The person goes to ShopRite and buys you the bread they prefer, which is still a bread. And then comes back to your disappointment. Say, no, why didn't you buy this one? You just told him to buy bread, right?
Yeah.
So that other bread you prefer is intentional when you express that map. It's there, right? But it just wasn't represented in language, right? One of the guys when I was in the university told me that, anytime you're describing a noun, your dictionary is poor. Mr. Obina, he works in Shell now. He said, anytime I'm describing a noun, my dictionary is poor, which is true. Because you're supposed to call the name of a noun. Not so? Exactly. So he was trying to tell me something that you can't describe something that already has a name. It's best you find the name and then use it. Okay? So all of us, and that there's another thing I want to tell you. One last quiz and we close. Choose any word in the dictionary, define it exactly the way it is in the dictionary, and you have this. Any word. Choose any word, English word.
Exactly.
And define it exactly as it is in the dictionary.
But there are different dictionaries.
Okay, choose a particular dictionary. Oxford, Cambridge. Did you check it before? Okay, you have. So which dictionary and which word? Oxford, which word?
Man.
Man. Go ahead. Fire. Okay. What's your dictionary? Oxford. What's the word? Eh? It's not a word. E. Okay, A. Okay. Go ahead. Yes. Go ahead. Define it. Hold on. So A. So what does Oxford say after you encounter A? What are the words that follow?
Yeah. First letter of the alphabet.
Okay, let's check Oxford. Let's go.
Which kind of Which kind of quiz?
Okay, you want to try?
Man.
Which dictionary?
An adult male human.
Okay, let's open. Who has Oxford, by the way? Okay, there's no internet. Okay, so Emeka is going to have the 1,000, and if any of you were correct, you can claim it. If not, he will post back. Okay, but let us not lose the reason why this experiment came out. The experiment came out because none of us move around using words that we capture the denotative space. The denotation of words is a dictionary. Somehow we just use the connotative space, which is what the words mean for us in context and in use. That is why you cannot just mention an English word and say exactly the words that follow it in the dictionary. Nobody does that. But we manage to do what? Communicate because of the existence of what is implied. In short, when you talk, there are more things you have not said than you said. What of the prosodic effects? The prosodic effects of everything I have been saying include my tone, my rhythm, my rhyme, my gestures. Right? If you were listening to the audio of this lecture, you lose all the prosodic information, which come visually. And then each of us, based on our experience, also process and interpret prosody differently. So the territory is not a map. And there are some things that we just cannot represent to the machine for learning. Okay, there are more questions now. Right. Okay. Okay, yes, go ahead. We'll give room to those that haven't asked, you know.
Okay, I think one thing I got from this lecture,
yes,
permit, you can correct me if I'm wrong, is that in as much as we cannot express W2 in discrete ways, then artificial intelligence or AI cannot gain consciousness and emotions. True?
Yes, it just it can't process affect. Right? First of all, for you to process affect, you must have the body of a biological organism and its nervous system. We just have to start from the basics. Right? If we hold ourselves to strict standards when we talk about logic, right, and identity, okay, when you have one function, f of x, and you have an equation, this, we hold ourselves to such strict standards of equality in logic. We can now come out and say that the machine experiences something when it doesn't have a cell. I mean, the cells of your brain, are they not neurons? They pass signals differently from the cells of your eyes, different from the cells of your lips, tongue, everything. So the quantity of information in the cycles of your body, Krebs cycle, metabolic cycle, the quantity of, I say there are 1,000 trillion cells. And the biological moment is 10 moments in a second for man. 10 moments in 1 second. That's why this thing, which under alternating current, is coming on and off 50 times a second. It's steady in your eyes because of persistence of vision. But if our moments were like 1,000 in a second, this thing would be as discrete as the cycles of the blades of the fan. Right? If your internal moments are faster than the phenomena in W1, you will make it discrete. If it is faster than it, then you go continuous. So, having said that, 10 multiplied by 60 multiplied by 60 multiplied by 24 gives us 186,000, right? Yes. Moments in a day. That's the quantity of moments, right? If you are to map attention, that is actually how you are. You are picking that. But the thing that happens is that at times you just enter into this coasting zone, right? Like if you are watching us now, hey, they're about to score. The moments they can squeeze, or right? Because you hear at times that time is elastic. So I don't feel that the curvature of that hyperbolic time maintains one strict. Right? At times it goes like this. At times it goes like this. Like if you're anxious and under fear, 4 minutes looks like 1 year. Right? So the what is happening in EAS is even what we have to dabble about, right? Then the things that are in the joint world are what they are. Signal, light, discrete, continuous, my words, your hearing, just the normals. The drum of music around your culture, people that, everything, what is signal. How that thing is affecting the organism is a completely different dance, right? And indeed, I do not see how the AI can have effect for now. Okay, just one question from you there. Go ahead.
Is there a probability that in the near future, the machine learning will be able to take in codes from the biological community? Because according to you, the machine learning cannot understand the affect, which is only what biological cells can do. But with the way the world is moving, it is estimated that it can, like machine learning will be able to do that. Is it truly a possibility, or it cannot happen at all just for the fact that machines don't have cells, or can it be eventually done? Like coding the biological sequence into a machine. Like this concept of moving your consciousness from a human, like a dying human being into a computer so the person can live forever or something like that. Would that type of thing be possible?
So those are those things of the silicon-based life versus carbon-based life. So two things. If you read John Seale's article, 1980, Stanford, the machine understands exactly nothing. It just doesn't understand. And it doesn't understand because there are no grounds for the symbol. There's no interpretative space for the symbol. The machine doesn't interpret nothing, just manipulates these symbols formally. Formal manipulation is what an algorithm is, right? The symbolic space doesn't matter. Today it can be 1 to 0, A to Z, Greek alphabet, even signals, right? After all, now they are getting signals from the animal kingdom, and the machine is telling us things about those signals in zoology. So once you can take it to the symbolic space and to vectors, the machine will learn something because you're already in statistics, remember? So I can tell you that the machine is going to learn anything once it is represented statistically. That's one. Secondly, you must make a very great difference between inference about uncertainty and uncertain inference. This came from Leibniz. Do you know Leibniz? The guy that started calculus with Newton. Now, Leibniz says you must distinguish between two types of inference. The inference about uncertainty, which is what you just did. Is there a probability that the machine... Of course, there's always a probability. Probabilities go between what? 0 and 1. Even if it is 0.00, of course it exists. In short, it is possible. It can be conceived. That's what? Inference about what? Uncertainty. What about uncertain inference? And uncertain inference are the things that organisms do. Now, when you make an uncertain inference, it's not just enough that you learn if you are wrong. Most times you take the consequences. Blame. You become sorry, right? You were wrong and somebody lost something very precious, right? Then there's a burden of guilt. Have you seen the difference between inference about uncertainty and uncertain inference? One has meaning, the other is probabilistic, right? So we can't be confusing the things that are real with the things that are mathematical. I'm not saying mathematical objects are not real. I'm just saying that those things that have real import. Example, you come to your village, somebody says, bros, this is my last 5K. Should I bet Barcelona Arsenal 2-1? Or should I just hold it? So, if you tell the person, there is a probability that if you hold it, you will lose 2,000 naira, and there is a 0.02 probability that if you bet 2-1, you will make extra 2,000 naira. That is inference about what? Uncertainty. But if you tell the person, bet you win, that is uncertain inference. Because if the person loses, base follows. And if the person wins, that's one point of induction that makes you a potential prophet. Next time you around, another point of induction. Next thing, they'll just run around you and say and start collecting from other people and asking you what, right? Because you are right every time, that means the pattern becomes a what? Statistical law. That is how the machine learns. So where there is no affect, there is no reason why we shouldn't throw about probabilities. But when the space of affection is involved, somebody may be getting hurt somewhere, right? You are in the space, aerospace and dynamics, you are producing this drone that should target somebody. The fact that a drone should target a human being is even a problem for me. But then you target it and say that it will blast in a radius of 2 meters with a probability X. And the probability that there will be 2-3 casualties around, collateral damage, is 95%. And somebody says, go ahead, policy approved. You see, that kind of impersonal way to deal with inference about uncertainty that has affect import is part of the reasons we must continue to distinguish between meaning, or the intelligence that bears meaning and one that doesn't. Right? So the lecture may have come in this way, but it would have great signification, which is what I hoped it will. Over time, the material Emeka will circulate, but keep thinking about it. Meaning with intelligence, it should not be in the same dimension with meaning without. And the specific case of meaning without intelligence that we have today is called artificial intelligence or machine learning. This is the last question. Okay. After this. So 3 more and right? Do we do 3 more?
Yeah.
Okay. 3 more. We're capping. 1, 2, 3. Fire, please.
Trying to recall my question.
Yes.
So, but it's actually 2 questions.
Okay.
So, the first question is okay. Actually, I'm gonna say thank you for the topic, intelligence and meaning, because all along I was trying to find meaning in all of the thing.
Right.
So I found the meaning, but then I wanted to actually ask a question, basically to get your conclusion in a way.
Yes.
So, like first of all, the question is from talking about it, like the guy they asked the question about the whole ride, given that you said that meaning is found in biology, and you've proven so many proofs, and that's true. So he now suggested, or talking about how that you've shown how that there are trade-offs, given that with biology there's a trade-off, and it's working with such machines and artificial intelligence, there are things where they advance better. So in some case, just like the natural human being, is always trying to find a way to bring all advantages together so it can have a 100% working system.
Yes.
So you now talked about joining a system where you bring the computer and you merge with the human. So
those are the cyborgs.
Yeah. So I thought we are going in that direction,
Yes.
and that is basically going towards transhumanism. But
Yes.
the response you gave him actually got me intrigued. So then the question that I was going to ask now, based on that response, is basically, what was the reason for the whole ride? Because in the my study in some of these things in psychology, I found out that some of these theories, they were not found last year or 5 years, 10 years ago. They were from long time ago.
Yes.
So they knew the outcome of social media, outcome of TikTok, even before it existed. So what is the purpose of the whole ride?
Yes.
That's my first question.
Okay.
Then the second question is, what do you call it now? Yeah, so now saying that meaning is found in biology, and that's beautiful. So in the whole thing we see in biology, one of the things that's everybody going through life trying to find the meaning of life. Now there's one certain aspect of biology that intrigues every single person, which is life. Life. So one of the things with anything bio is that they tend to show a beginning and an end.
Yes.
So my question is that, what's your opinion on that? Do you think that is the purpose of biology, or is that the purpose of biology, or is there something extra?
Something else. Okay, let me take the 2 very interesting questions. And first ones, why was the ride? Well, there's a commercial dimension to it, right? That the internet exists means that people that are producing some of the things that are used to power it are also making what? A living out of it, right? There's a curiosity aspect to it. And some of this started with Alan Turing, when he asked the question in his article, can machines think? And since then, the Turing test has gone different rounds. Different universities keep updating different versions of the Turing test. So there's that curiosity aspect to it, right? Are we able to create something that thinks like us or even possibly outsmart us? And the evidence before us is that the machine has over the years been doing what? Dusting humans. It beat Kasparov to chess. It beat the Chinese master in Go. It solves GRE and GMAT better than the smartest human beings now. That's ChatGPT 4. You are not even in ChatGPT 10. Imagine what ChatGPT 10 will be doing, right? So if you look at the trajectory, there is a commercial dimension to it, there's a curiosity dimension to it, but there's also the semiconductor aspect to it. Because the chips that are the GPUs that are powering some of these training models are simply performing very fast addition. They are doing the same operation, a binary operation, but doing it faster, right? And in a hyper-threaded kind of algorithm. That's why the delay of AI is actually the delay of chip manufacturing. And this basically uses the extreme ultraviolet lithography. So you are bringing atoms at the space distances of 4 nanometers now. Of course, at some point in space, the proximity of 2 atoms, you must begin to feel quantum effects, right? And therefore already, the quantum computer is already, right, moving ahead in case you max out Moore's law, right? So the chip industry is on its own. The content industry is on its own. Media is no more TV. Hardly do people watch NTA in TVs. They now either watch NTA in their phones, right? So different professions have reacted to the reality of this information communication revolution. Okay. And you know when Maxwell's equation came? So the dawn of the century. And that's still what is powering all the things, right? And with the optical fiber. So maybe that's the rave. Commercially, man making a living out of something, curiosity, scientific curiosity, and experimentation is enough to get us here. But philosophy has also proceeded, obviously. Those in philosophy who are the deepest thinkers that we have also talked about how we have to be very careful with our relationship with machines, right? Different philosophers from different climes and cultures. So a lot is going on with that, but let's leave it there. The second question had to do with, remind me again? Life. Now, oh, wow. How many of you know Erwin Schrödinger? Schrödinger's equation. Yeah. He actually wrote an article called What is Life? To be a very good reading. Now, why I like that article is because the machine learning, again, one thing you will never come out of is entropy. Have you heard this word before?
Yes. Yeah.
The best way to say it is the entropy is the information that is available but that is hidden from you. Example, your back. Right? Your back. Mine. It's there, there's something there, but you can't see it. Right? Your visual field can't see your back. Or somebody behind you can see your back. Okay? Another entropy is what is behind the curtain. If you've not seen before, even if you've seen before, what is behind it now is available, but what? Hidden from you. That's entropy. There was something Shannon did, smart, in the mathematical theory of information. He was able to, given any probabilistic distribution, quantify the what? Entropy. So even if we can't know the statistical law driving this, we can have an equation that can represent for us the information we do not have, or the uncertainty. The quantification of uncertainty is what? Entropy. So if given a distribution, if you can't tell what is there, you can tell at least what you can't see. You know, the quantification of uncertainty is entropy. Now, biology happens to be, at least thermodynamically, a reversal of entropy. As you know from the second laws of heat, materials tend to higher disorder. Remember when we came into the room? It was more orderly than now. Right? Just take a look at the floor. So just somehow, the material order tends to get to what? Disorder given time. Now, biological processes reverse that disorder. That's why he called it negentropy. So when you have a cell produce waste and take nutrients, it is doing it to get itself to a greater state of order. Because if it's doing that exchange with materials from the environment and discharge, and it tends to a state of disorder, then it does what? It disintegrates. Who? Well, exactly. So in chaos theory, you are going to find the existence of dissipative structures. You are going to find femtoprocesses at the micro level that create macro order. Have you heard of seen those chemical equations that change color? Turns blue and turns red and turns blue, right? So that's a lot of microscopic chaos giving long range coherence, right? So, and Ilya Prigogine got a Nobel Prize in chemistry for predicting those kind of processes in chaos. So, in the regions of far from equilibrium, you have chaos. But that thing we are calling chaotic brings about long-range macro order. That's what chaos theory is saying. Okay, so the cell is chaotic in its operation. But we know that the DNA still stays, protein synthesis still continues, waste is produced, nutrients are assimilated, and growth happens until it does what? It divides. And as it divides, the mass of the organism does what? Grows. Beside my window, I was looking at 2 eggs. Before the 2 eggs came out, first of all, there was a nest. Before my eyes, I was looking at a window and sticks were just coming together. Next thing I saw something around. That's what we call a nest. A bird's nest. Next thing you know, I saw 2 eggs there. Every morning I'll come out, I'll just look. Then after some time, the bird was now sitting on top of the eggs for a long time. Then I think I traveled, came back. Next thing I saw 2. And next thing, they flew away. Then they came back. Then they flew away. Then they came back. This happened for like 1 week and they disappeared. Right? So biological processes tend to create spontaneous order. And once life leaves a material, what happens? Decay sets in. Degeneration. That's why all abiotic mass does what? Tends to disintegration. So it's almost like the entropy, if the chaos you see in material things, if there's a statistical law powering it, AI can learn it. But you just can't learn the one in biology because of spontaneity. Right? That's why biological organisms are autonomous. Somebody will just turn like this and start walking away. Right? Or you see somebody say, I'm going. Why now? I'm going. Don't worry. Okay, so we'll see tomorrow now. But if you check why the person is going, there may be very internal processes driving the reason to walk away that are nowhere representable by any measure of observation. It can just be fear or phobia. Okay, let us look at the special case of phobia. Those that are aquaphobic would have chills and be shivering even water is reaching below the knee. They feel they will drown. There's no possible way by the laws of physics that they will drown water at their level, but it doesn't mean that. So where is that fear? And leads to your question, how do you quantify all those kind of non-representable data sets? So biology is complex. Biology is, for me, reversal of what? Disorder. And then the very, it used to be called vitalism. It used to be called vitalism earlier on, but it just means that life is mysterious. Of course, life was made and created. Otherwise, we wouldn't be even here talking, right? Philosophers have thought, what if there was nothing? There would have been nothing. But there's too much evidence to show that this particular phenomenon defies the second law of thermodynamics. That's why you brush your teeth every morning now.
At night.
You reverse a lot of what? Effects. In doubt, leave it for 1 year. Check the color. Yes.
This is the last question.
Okay, yes.
So, after everything that you've talked about,
yeah.
In my mind, I was like, okay, how do you now quantify the things that we understand?
Yes.
Then I was now like that, okay, so this is not ethical, but if you are to carry someone's brain now, maybe someone that died, but now you carry the brain and use it as a test subject, and then you now start to collect sensations from people and then recreate those sensations on that brain set to now understand what basically maybe this person will have done with that brain set now.
Yeah, I mean, I'm very, very happy you keep saying that it's you will understand, not the person. I mean, how can you understand for another? The beginning of the ability to quantify understanding implies that we'll stop going to school, because then I can do what? Transfer all the understanding. Your professor will just transfer all the understanding they have about the course at the beginning, and you go home. The reason why that doesn't happen is precisely because of the world of experience, right? I mean, some things just take time. Like, nobody observes 2 sunrises in a day, unless you're on a fast F-16 jet. You see one, then you fly faster, then stop another place, and then you, right? You typically see a sunrise and then see a sunset, and wait another what? Exactly. And each type of experience separated in its own due time. So, material reductionism maintains that inside that material mass called the brain, you will see something. But the evidence that the localization of experience is even there, or even the localization of understanding. By locality, I mean X and T, space and time, here. Elon Musk, is he not doing it? What did he read from the one he did? I read his article. It's still alpha and beta waves. It's still signals. Right? Check Elon Musk's article, man. It was a mice's brain they used, neural link. Yes. You will keep seeing very complex, almost pathological functions. Now, I keep saying you want to jump from signal into what? Symbol. No. The walls are covered by a Markovian blanket. It can't pass. One sign is governing signal. The other is governing symbol. One is after effect. The other is cause and effect. Just even the laws of quantity will apply in affect space is funny. Like it is, you know how somehow it is to quantify each. Give it a dimension, a scale. Ah, this is from 0 to 9 inches. This one that happened to you is 5. It may look impossible today. I don't want you to give up that curious mind, but I also want us to work with how long and ancient the world is, right? And see that maybe this thing is not about us trying to do what the machine is doing. What it's doing is doing it statistically. And what we do, it can't do it by any means. That's my point. So we should, if we understand that difference, maybe there are some experiments we won't even bother doing. Right? The last one was him, yes.
I will start by saying that I'll start by thanking you for the exposure anyway. To be precise, I'm into the Department of Statistics.
Oh, beautiful.
Yeah, into data science, precise, though not too deep. I see machine learning as something I actually want to venture into. But with this whole thing I'm seeing today, I mean, it's looking like it's beyond statistics, even though we're still leveraging on statistics.
Yes.
I mean, the context of biology cannot be overemphasized when it comes to this machine learning. So how do you tell somebody professionally now, venturing into machine learning, with respect to what it means to take into note? Because this is beyond statistics, because we are bringing science, biology into this whole thing, and I can tell you the last time I did biology was my SS3. Yeah, so from now, like I'm just saying, how do you advise somebody now? Do you think it's, because this is so encompassing that it's like it does not just, because what we do in Department of Statistics is basically distributions and probability and inferences and all that, but it's beyond this whole thing. So how do you like tell somebody or advise somebody venturing into machine learning, to precise?
It is, the person is very lucky to be in this age and time, right? The luck is that you are sure to find a job once you graduate. That's the good side. The downside is that you are sure to be out of the job faster enough, because the AI will soon start doing what you're doing. Right? Have you seen the two sides of it? So the AI gets better at an exponential rate. It doesn't get better at a linear rate. So when the AI is currently causing a depression in programming world now, right? The depression is that if you just simply think about the quantity of new code that is injected into all the repositories around the world, And the fact that the AI can converge its learning on it in like, I don't know, X, which is dependent on the convergence rate of the learning model it's using, it implies that it may gain a capability that you will become in 2030 now. So somebody, you are running with somebody, and each step the person takes is like running the stadium 10 times. And then it takes another one, runs it 10 times. So, I mean, you at a point, you will stop running, right? Because you just know that there has to be another way to beat this thing, right? So I don't believe we will be better than it in statistics, given that I keep saying that the computer is better than us in calculation, sheer volume and velocity of calculation. So you reduce a problem to calculation, the computer has won. But what of incomputable functions, like this waitress function I told you? Something that is everywhere continuous and nowhere differentiable. Pathological functions, right? What of low probability events that have high consequences? Something that happens once and only once. It defies statistics because it's not going to repeat again. No wonder the most secure ciphers in the world use their keys once, the one-time pad. And that's perfect forward secrecy. So you will beat the machine in those things that are non-statistical. And guess what? We can learn things that are non-statistical. Right? You can learn, there's nothing statistical about having faith. Yes, absolutely. You have faith, it is an action, yourself you accept, and then that's it. It completely turns your life around, right? The machine, there's no hope for it to really understand what you're doing at that level. Of course, you don't exist in that dimension. That's why I kept saying about what? The after effect, the experience, the world of... We experience differently. That's even if at all the machine experiences. It's just maths at the end of the day. But those in statistics now will have a job. Those in statistics will have a lot to tell us about future learning models. Those in statistics will bring out newer models. Those in statistics will tell us the best way to represent difficult to represent data sets, right? And those in biology will equally join because they'll tell you, see, I want the machine to learn this for me and this is how, right? Like those doing the oncology research in cancer, they are bringing out a lot of what? Data sets for machine to learn, right? In different ways. And a lot of that is going to be going on for quite some time. Difference being that it is also an age where when you sit in front of the computer, you now have to be afraid of what the computer can do faster than you, right? Than what you can do. They say, oh, the creatives, is a time for creatives. You know, prompt engineering has come out, right? Prompt engineering is programming with words. In our time, we used to program in assembly language. We used to put things inside registers and check if that thing will work. Right? Now, you are writing English and then the computer is producing essays for you. And if you don't like the flavor, you tell it again. Just it's like you're doing a pin. Do like this to bring out one. Do like this. Even art. Have you not seen Gemini? Is it Gemini? Which AI is the one that produces art? Images. ChatGPT, but there's one that is more optimized for images. Okay, there's video. Do you understand? So the AIs are even specializing now, right? Do you understand? The AIs are so. This is the time for it, and I've told you the upside, and also the downside. That anything statistical, you leave it for the machine. Sooner enough, a learning model will come out. When the large language models were all there was a special article that came out. Attention is all you need, right? It's quite advanced article, or well, at this level, but you can still try your hand on it. And immediately, the breakthrough in those research was applied in the learning models. The learning convergence for the large language models just went up. So you'll be having breakthroughs like that in different models across different data sets over the years, right? And okay, Amy, does this help? So there are pros and cons for your question.
Sorry, some of us that the profession of you have to give hope to young people, you know.
Yes.
Every year I meet young people from secondary school first year.
Yes.
They are full of hopes in life. So, and sometimes they don't know how to direct themselves. Sometimes, they look at you as, okay, you that have been living in this place, you have more experience. So in this area of coding,
Yes.
regarding this AI,
Yes.
My question is, when we were in university, they will tell us if you want to succeed, pick a program language and learn it very well.
Yes.
So some of us went and grabbed fat textbooks in Java and we're reading it.
Yes.
And we believe that that thing would give fruit in future.
Exactly.
We did not see the fruit then, but we spent nights coding and some of us made it that way.
Yes.
Some learned all kinds of things, but they were coding. Now, this AI that is coming now,
Yes.
the impression I get sometimes that there's not even any need to open any programming textbook since the robots can code. Now, but the fear I have with that is the same thing that has happened to Nigeria or Africa with technology in general.
Yes.
We drive cars a lot here, but we don't make any. So AI is still being made by some people.
Yes.
So, and what do they use to make that AI? It's the same coding.
It's the same coding.
So when they tell us you don't need to code, after 100 years, it will be a small set of people that know that coding, and they'll be controlling everything.
That is true.
I don't know what's your...
Okay, so this is very profound, and yes, it's true. You see, coding has bifurcated. Are you coding the classical computer or the quantum? Which coding are you talking about? Because quantum computing is a whole different type of coding. And I don't know any AI that is doing anything there. Right? Remember, the computer is 3 states now. Right? Up, down, and superposition. That's the quantum computer. Shor's algorithm has been proven there, and that is sure to beat the factorization of large prime numbers. So your internet banking will break soon. Don't be scared, but I mean it. Because once SSL stops working, that's it. No more internet banking. It will factor any of those modules for the algorithms of RSA. So this has brought out the region of full homomorphic encryption, which uses lattices as the underlying hard problem. So I'm saying that the world of programming is still going on, but it's going on again into what? Quantum. Now, back to the classical. It is ever more relevant to learn the rudimentaries, because we still have registers in CPUs. We still have microprocessors in CPUs. We still have ALUs. We still have RAM, right? And if you don't program at that level, especially C language, if you don't program at that level, in your future, when you are trying to design something, you will just call a library. Because another programmer has made a library available to you. But that library may be using disk to do an operation that you need to happen quite frequently. And that will just limit your algorithm. Okay? But if you learn those deep rudiments, you may say, this thing writes to disk. Let me put this in RAM. I'll create a RAM gallery so that I can read from RAM, which is faster than disk. You would be able to know the millisecond differences between calling 2 different functions. These things happen when you are coding at that level. If you leave it and jump to Python, you're almost close to English. Then if you leave it and enter prompt engineering, you're speaking English. Right? So we can't still leave the engineering aspect of programming and what it also does to your world of experience. Engineers are people that design systems, right? If you don't deal with design at that level, how are you going to create? Right? You are just relying on the statistical patterns in the code. When AI writes, it writes codes from the last code that has been written. It cannot write code that has not been written before, right? Under a very, very special context. Or it cannot combine code, right, that would give a particular effect, a particular desired effect. So today I work with Java. AI says up, AI says down. I don't even know. It's still Java. There is a lot of problems, right, in our environment that Java can solve that it has not solved. There is even a lot more that C can solve that it has not solved, right? And then as these processors are becoming more complicated, the machine level instruction sets are becoming, who was even telling me? I think it was Linux Trovals. You know Linux, the guy that wrote Linux. Right, he was giving a talk, and he said that there are special routines in the Linux distribution code base that are written in assembly language. I mean, you won't have it any other way. Every AI still runs on an operating system. Hello, guys. Does the AI not run in OS? Does it write its own OS and run on it? It doesn't, right? So you still have those levels, and like Emeka rightly pointed out, those in those levels of specialty will begin to reduce as people chicken out into what is more convenient. If these smartphones are experience blockers for children, it means that you don't make your reasoning tough. It's almost like somebody who solves problems without calculators and solves them fast, right? There's something the person is gaining. You can tell the person, no, I mean, it's just arithmetics that I'm doing, right? With the calculator. I still go ahead to solve the engineering problem. I just have to do what? Do the arithmetic on the calculator. But you see that person that is doing the arithmetic with the head, right? It's something they are gaining more than you. Long enough, across large enough domains, right? The person may be a much more resilient thinker than you. And I tell you, the experience you get in reasoning, in sports, may come into what? Design, right? May come into what? Debate. May come into different life processes under different life circumstances. The brain is still the organ you carry around everywhere. And it's still the lens through which you do what? See a lot of things at the background of your experience. So I'm not saying that the AI, if you write easy code, the AI will do what? Throw you away, right? But if you specialize in okay, there was just a little anecdote. There was a very special system we were writing for the federal government. Then I had a group of the team is smart, very tough, things are intense, and I told them that, what are we doing about quality assurance? Right? You write the code, somebody has to test it, right? In the real world, to be sure that it's of high quality. Okay, we are doing this. I said, are we doing unit testing? Now, unit testing is a kind of self-asserting function, a kind of function you give to the computer to check for the internal consistency of functions. Like your API. You write an API, you need to put a unit test for the computer to check that API for internal consistency. And some of these deployments have thousands of APIs. I said, what's our unit test coverage? It says 0. Right? I'm just telling you where AI could help. We now took one AI tool, right? Or a tool that has one AI component called Jakuku. That if you are pushing your code to production and it doesn't have unit tests, it will fail it. But you can tell it to fail 40%, 50%, 60%, do you understand? Up to 100%. If you set it at 100%, every code must have what? Unit test before it passes. So we're struggling with the unit test coverage, 1 month, 2 months. And I'll call the head of engineering and say, raise this Jakuku to 100. Let's stay on it until we do what? We move. We finished. It had 100% unit test coverage. Then an external firm was contracted to do what? To do quality assurance on that code. That's, at times, when you're doing a code that is very sensitive, right? Imagine those that are coding in NASA or those that are coding in SpaceX, right? You are coding the instructions that are sending a rocket that has a lot of hydrogen fuel, right? A ball can cause an explosion. So you almost have to test and retest, and do you understand? And those unit tests are very good because they are machine run. And they were looking at our code, and they what they called to tell us that, wow, we are amazed that you guys are writing unit tests. Do you understand? So it's not the AI at times to do the coding for you. It may be the AI to get a quality function for you. Do you understand? So if you hear that the AI is entering the programming world, it's not to replace the very thing you do. Because again, remember that the very thing you do is changing in real time in W1. Right? Make the code to do like this. do like this. Then make it to do like this. Ah, no, 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 they've cancelled it. It has to now do like it, right? It's still human beings that have to interact, understand that new requirement, translate into what? Business requirements, software requirements, specifications, design, code, quality, test, release, deployment, and then acceptance. Do you understand? So we are basically saying that world of programming hasn't ended. World of good programmers may be reducing because of people that choose the pathway of convenience. Right? World of very intense, thorough thinkers may be reducing because of those that do what? Quickly submit to the smartphone. This is A to B. Oh, it's not true. Let's Google it. Really? Yes, it's good to Google, but the thing that Google gives you, how did you question it? Do you know how many search pages that go to page 20? Most people search Google and start in page 1 or 2. That thing that shortlisted itself in 20, is it not part of the result set? Right? Sponsored ads may fill your whole what? First sheet. And they may just be commercially driven, not necessarily addressing, right? Semantic ambiguity is coming. Somebody twists an article and it changes the meaning of the sentence. Right? These things happen. So we still push for what? Retain your original affect space with rigor. Have that scientific rigor around you. Work with a calculator and a pen. If your smartphone is a problem, use it only during holidays. Right? Just be that way in this time because it will just finish faster than you think. How many of you are finally? It's a game over. How many of you are a year before final year? How many are in 2 years before final year? And how many in the first fresh? Yeah, you're the luckiest ones, right? And those two in the finals also equally lucky. Everybody's lucky in short. What we are saying is, the rigor is essential. So you've seen an industry practitioner that uses a Nokia 1510, right? It tells you something about the potential ability for the smartphone to distract, right? And I tell you again, in the workplace, I told one of the engineers that your efficiency is going down. I know you. You are very, very good. Your efficiency is going down. He said, no. This thing went on for like 2 months. I told him, do you measure your screen time? He said, no, he does. I said, just measure it. You know, he measured his screen time. Do you know what he saw? 4 hours. You don't know what micro time is. Micro time is, you keep it. Another alert. Let me just reply this. You keep it, right? Done large enough in a day, you congregate that, right? There you go. Are you with me? So when he saw the empirical evidence that his screen time was 4 hours, he got this. He still has a smartphone, right? But during the work hours, he's on this. Because this will give you call and SMS, right? And in the call is audio, there's no visual. If there's SMS, you have the freedom to reply maybe during break. And then productivity has a chance to. And this is normally how it is in Europe. You go to a typical bank where you have 48 programmers. The only phones you find there is what? Those analog phones in the desk. Everybody's phone is in the locker. Right? So that's the real world. In the real world, your attention, time, and energy is a finite resource. It's not infinite. So conserve it very well. Thank you, gentlemen.
Thank you very much, Engineer Osuagwu. I don't know, can we take